Morning.
Good, BK Roy sir, good morning. Sir, okay. Thank you, sir. Welcome to the day 3 of 1 week online international faculty development program on machine learning and computer vision applications, research challenges, MLCV 2020, organized by the Department of Computer Science and Engineering, NIT Silchar, under TechU3 as training activity with Guwahati University Institute of Science and Technology, Assam. Good morning to one and all present here in virtual mode. Participants, this is to inform you that we will post the attendance cum feedback form in the YouTube channel at the end of each expert talk, and it will be available for 10 minutes. And as the number of participants are less in number, it is also requested to post the relevant queries. Otherwise, there is a possibility of miss the relevant questions. Today, we have 3 eminent speakers, Dr. Peter Sayung Singh from Sanwe University, Malaysia, Professor P.K. Das from IIT Guwahati, and Sri Jyoti Prakash Medhi from ZUIST, Assam. Moving on towards our first lecture of this session of Day 3 MLCV 2020, it is my privilege to introduce Dr. Peter Sayung Singh from Malaysia. Dr. Peter received his PhD in Information Technology from the Faculty of Computing and Informatics from Multimedia University. His doctoral research work was on the performance evaluation of multimodal biometric systems using fusion techniques. Dr. Hu is a senior member of the Institute of Electrical and Electronics Engineers. Dr. Hu has published a number of papers related to location intelligence, multimodal biometrics, action recognition, and text mining. He is currently a senior lecturer in the Department of Computing and Information Systems, School of Science and Technology, Sanwe University, Malaysia. Sir, now may I request you to kindly start your presentation. Sir, kindly.
Okay. Good morning, everyone. Thank you, Madam Chairperson. Thank you, Prof. And thank you, Dr. Naresh, my friend and collaborator. And this morning, I am very privileged to be given the chance to share my thoughts in this esteemed conference. So I thank you for the kind introduction, right? My name is Peter, and I am in the Department of Computing and Information Systems. You can see my email address on screen, and you can also see my LinkedIn address as well. So today, I will be talking about GPT-3, and I'll be giving an overview of how this language model works, what are its strengths and weaknesses, as well as challenges, and how has it been used for producing interesting machine learning applications, particularly in the area of natural language processing. I will also perhaps show some resources that will help interested learners to actually get started, if not with GPT-3, then at least with GPT-2. So allow me to carry on with my presentation. Nomoskar, I hope I've gotten that right. And I believe, or I hope that the script in Assamese is correct as well. All right, so India has a special place in my heart. For the last 4 to 5 years, I had the honor and privilege of going to various institutions of higher learning in India to give talks as well as to collaborate and meet esteemed researchers and lecturers and intellectuals in the fields of computer science. So currently, I am working in Sanwe University. We are a private university in Malaysia, and we are located in the state of Selangor in a town called Petaling Jaya. So this is a picture of me by the roadside in Leh, Ladakh. That was back in 2017. So like perhaps some of you, I was quite taken with the movie The Three Idiots. And in that movie, the cast went over to Pangong Lake. So I got together with a bunch of friends who were like-minded. And in 2017, we made our way up to Leh Ladakh. And I still have beautiful memories of the scenery and of the brilliant people that I've met over there. So I would like to again congratulate all the organizers who have been doing all the hard work behind the 1 week International FDP, Machine Learning and Computer Vision 2020 online webinar. I think it's a wonderful effort to want to share knowledge among fellow researchers and academicians at the institutional level. I am especially pleased to be invited by the National Institute of Technology, Silchar, and the Gauhati University Institute of Science and Technology in the lovely state of Assam. So that is one corner of India that I've not been to yet, right? Bordering Myanmar. It is the very northeastern tip of the country. And I hope that I will have the chance to visit once all the travel restriction due to the pandemic is lifted. So I work in analytics. My PhD was in the area of multimodal biometric authentication, but I don't do much work in that area except for the application of fusion techniques for the purpose of machine learning. So my current research interest is chiefly in the area of location-based analytics. This is where I try to use the geolocation information that is related to a particular event or a particular media as context. So I have a student who is due to graduate soon, and we've achieved good results where we fuse geographical information as context to word embeddings. I also do some work on sensor action and activity recognition. When I completed my PhD, that work was one of the first that used the gyroscope and accelerometer for the purpose text mining. And I am also looking at how field shot machine learning can be helpful, and that is particularly related to what we'll be talking about today. And I'm also looking at ideas such as fairness and bias in machine learning. So apart from my work as an academician and a researcher, I also wear a consultancy hat, and I have clients ranging from the government of Malaysia, where I've done advisory work for the development of big data use cases. And I've also done paid commercial work for text mining of SMS-based customer complaint. And also in the area of location information, I have also worked on creating a advisory system for determining the suitability of a particular location for a particular type of business. So this is me in a nutshell, and allow me to move on to a bit more introduction about where I work, and then we'll start with the actual sharing or actual lecture. Okay, this is a photo of my country, Malaysia, right? So Malaysia is in Southeast Asia. So if you have heard of Singapore, then we are north of Singapore. And if you have heard of Thailand, we are south of Thailand. And we are a country that is situated on two landmasses, right? The peninsula, which is connected to the Greater Asian landmass, and Sabah and Sarawak, which is on the island of Borneo. And in this same slide, you can see some iconic buildings that we have in Malaysia, including the world's tallest twin tower, right? The Petronas Twin Tower. And we used to host our own F1 races in our Sepang International Track. So allow me to share also a bit of information about my workplace. I work in Sunway University. So Sunway University started off as a college in 1987. It was set up by Tan Sri Jeffrey Chia, a philanthropist and businessman who wanted to give back to the community. And it was his first foray into the higher education landscape. In 2004, right, 16 years ago, the Malaysian Ministry of Higher Education gave the permission for Sunway College to be upgraded into Sunway University College. And till today, Sunway University College exists as a separate entity from Sunway University. In January of 2011, Sunway University achieved full university status, and it has been a 9-year journey. So I think as far as universities are concerned, we are a young university, but we aspire to be among the very top university, if not in the country, then in the region. So currently, Sunway University is a multidisciplinary university. I belong to a department that is parked under the Faculty of Science and Technology. And we have two other sister faculty, being that of the Sunway University Business School, which operates in the domain of business and economics. And we also have a social science school, which is the Faculty of Arts. There are 3 centers, and there are plans to increase the number of centers and center of excellence. So currently, the existing centers are for tourism, hospitality and culinary management, Center for American Education. This is where Malaysian students who wishes to continue their studies in an American institution of higher learning would do their pre-U courses. And we have a Center for English Language Studies, which is focused on language skills. We've also started a Sunway Institute for Social Entrepreneurship. So as a philanthropist, Tan Sri Jeffrey Chia is cognizant about the role of philanthropy in enabling those who are marginalized and underprivileged. And I believe he believes that one of the best way of empowering those from those kind of background is to give them a leg up via social entrepreneurship. So this is a nice glimpse of my university. So we are very much a city campus. Almost all our facility is located in this building over here, right, in a single building. And my office is somewhere on the 3rd floor, overlooking the other side of the Sunway Township. Now, Sunway University is in this township known as Sunway, and it is next to a theme park, It is also within walking distance to a shopping center. And thematically, the shopping center has a Egyptian feel to it. So if you guys ever come to Malaysia and you wonder why there's a pyramid, well, that was a design concept. And we have our own, very own Lion of Sunway situated in front of the shopping mall. So although we are part of a business entity that has a presence in hospitality, management, even in outdoor and indoor entertainment, we are a serious education institution. And in my Department of Computer Science and Information System, we offer a few undergraduate degree program. So we have a Bachelor of Science in Computer Science. We have a Bachelor in IT. And we have Bachelor of IT with a focus or major in computer networking and security. We have a Bachelor of Information System focusing on business analytics, for which we have partnered with entities such as SAS. We also have a Bachelor in Information System focusing on mobile computing with entrepreneurship. And we have a Bachelor in Software Engineering. So our bachelor degrees are having the status of having a dual award with Lancaster University in UK. So students who graduate from Sunway University will not only get a Sunway University degree, but they will also graduate with a Lancaster University degree as well. We also are offering postgraduate degree programs in computer science and in information system. And these are largely by research. We have a PhD in computing as well. The two master's degree are again a dual award degree with the University of Lancaster in the United Kingdom. Having said that, we are constantly on the lookout for talented postgraduate students. So in fact, in 2021, we are reviving our research, not just scholarship, but research stipendship. So if you were to come over in 2021 and you meet all the requirements, then not only are tuition fees waived, but you are also given a livelihood allowance to pursue your studies. So now we've come to the actual topic on hand, GPT-3. All right, so GPT-3, I will be organizing my talk in this manner. I will give you an overview of what GPT-3 is, and I will examine some of the current issues related to GPT, especially in terms of the resources that was consumed in creating GPT-3. I will also explore how GPT-3 works, and I will do that by examining how the predecessor GPT-2 works, because GPT-3, as you will discover, it is a larger model, but it adopts much of the same architecture as the older GPT-2 model. Towards the end, I will highlight some interesting applications that has been built using the GPT-3 API, and I will also suggest a way in which you can get the GPT-3 API yourself, and perhaps a workaround if you cannot get hold of the API. And that will be the gist of this sharing session. So GPT. So this is a generative pre-trained transformers, and this is the third version. Now it is an auto-regressive model, an auto-regressive language model, meaning that context of one token, it is always unidirectional. It is unlike structures like bidirectional LSTM, which consider context for a token from two directions, from the beginning of the sequence and the end of the sequence. So for GPT-3, it is autoregressive. Context is given by surrounding tokens for a particular token of interest. Now, GPT-3, as the name generative is suggestive of, it is used primarily for the purpose of automatically creating human-like text. Now, of course, when you are able to generate human-like text, then there are many other tasks which can be accomplished by the act of generating text. And we will examine which of these tasks is GPT-3 good at and which of it is not so good at. So GPT-3 is created by an organization called OpenAI. And this is the same organization that released GPT-2. And then when they saw that it was very convincing in producing human-like text, OpenAI at one point pulled back the GPT-2 from being used. However, they relaxed their stance, and now we can use pre-trained GPT-2 model for our own NLP-related tasks. So now that we have understood a bit about what GPT-3 is, what has been said about GPT-3? So I'm going to sample from three gentlemen who gave their thoughts on GPT-3. And we have Carmack, who is the CTO of Oculus VR, the head-mounted device maker for virtual reality. And he used to have this opinion that AI research was ignoring automation of programming, right? It was automating everything, but it was not automating programming. And he suspected that this was because AI engineers and researchers had a self-preservation bias. Because let's face it, ladies and gentlemen, if we can automate the act of producing computer code, then we are automating our own jobs away, right? There's no need for you and me to be in this room to write code. Machines can write code for us. So here, Carmack was actually quite excited that GPT-3 was able to produce synthetically and synthetically correct programming language segments. There is a small video example that show how GPT-3 has been used to write Python code in relation to a body of text. So we shall explore that in a bit. Now, what do serious researchers say about GPT-3? So we have Sandberg from Oxford, and he said that GPT-3 is not smart. All right. However, he said that as dumb as GPT-3 is, it can readily do a lot of tasks that we actually thought required some form of intelligence. And I guess this idea challenges our own perception of intelligence. So GPT has this premise. If I give enough example of text, then the generation of text can then be done based on those examples without any notion of artificial intelligence. So Sandberg ended by saying that in the future, fake intelligence, such as that behind GPT-3, may actually be more dominant than real artificial intelligence in many domains. And we end with the set of comments by looking at what Altman said. Altman is the CEO of OpenAI. He recognized that GPT-3 is immensely hyped. It is, no doubt, an impressive model, but it has weaknesses and it doesn't do well at certain tasks. And we will explore all of that later. And for him, GPT-3 cannot be accepted as generalized AI, but it can be considered as the starting point for some form of generalized AI. So what is GPT-3, right? GPT-3 is a language model like BERT, and it is trained using next word prediction, right? That is the autoregressive nature of GPT-3. So what is a language model? So here, you understand that a language model, right, basically models the probability of word occurrence based on examples of text. In this case, we get a verse from the Bible, thou shalt, and if this particular language model has been trained on the Bible, then the word not would be picked up very quickly. And this is how a next word prediction language model function. Now, GPT, of course, was created for a reason. And basically, GPT was created by OpenAI to address three distinct set of challenges that was facing the natural language community. First of all, GPT, or the people behind GPT-3, recognize that if we were to have a dependence on large data set of label example for every natural language processing, then that need for large quantity of label example would actually limit the application of language model. You would need subject matter expert to label your data set for almost any task. And that is very time consuming, and it costs a lot of human labor. So as such, if we were to use or adopt a dependency on label examples, then the growth of language models will be quite slow. Next, if we were to depend on the scale of examples that exist today, you find that you will face two problems. You either get spurious correlation, all right, and these are natural relationship that occurs between concept due to the occurrence in the corpora or corpus of study. For example, you may see how certain words are applied to certain people group. And because that notion is so prevalent in the body of text that is being studied, so you get all this spurious correlation, which is not true. Now, the other thing is the training distribution, if it is not of large enough scale, would tend to be very narrow and limited, and it will not be very representative of how a particular language is like. Then the final challenge that GPT wanted to address was that of a cognitive understanding task. Now, for a human person, we learn by using a language. And in formal education, we are taught the grammar, which is the rules of the language. And as we grow up or grow old, we acquire an increasingly large vocabulary. So no matter how large our vocabulary is, it is never as large as that natural language processing models were being trained on. So in fact, the average human speaker of any language do not need large amount of labeled example. And the way we understand language is truly through the understanding of the rules of a language and also the acquisition of new vocabulary and the context of the vocabulary as far as the rules are concerned. So these are the three things that GPT-3 wanted to address. It didn't like the dependence on large labeled data set. It was also concerned, or the team behind GPT-3 was also concerned that the training distribution was too narrow. And in fact, if you look at how NLP models are built, it tends to be very domain or task specific. And finally, there was that inherent need to want to mimic how human make sense of the world. And this included the notion that humans actually do not need a lot of supervised data in order to perform their tasks. So that was the research motivation. And talking about the complexity of GPT-3. So GPT-3 is the third iteration of GPT, right? The generative pre-trained transformer. So the one that you can actually use today even, right, with very little hassle. And in fact, I've seen GPT-2 in use in your Google Colab files. So GPT-2 is divided into 4 variants, right? Each variant of GPT-2, which we will call a model, has different numbers of parameters. So let's just take the extreme version of GPT-2. the smallest, has 117 million parameters. And for the extra large version of GPT-2, it has 1,542 million parameters. Now, when you have so many parameters, for the model to optimize and to reach local minima can be challenging. But what did GPT-3 try to achieve? It wasn't satisfied with millions of parameters. It went into the billion level. So GPT-3 has 175 billion parameters. Okay, so let's talk about the data that GPT-3 was trained on. Now, GPT-3 is, of course, an English language model, and it was trained on the following element. 5 data sets were used. Common crawl, right, which is the entire internet. It uses web text. It uses listings and entries from books and Wikipedia. And what it was originally looking at was 45 terabytes of compressed plain text. And as much as they wanted to build it on 45 terabytes of data, what OpenAI did was to perform filtering, and you end up with 570 GB, right? Or 400 billion byte pair encoded token. So let that figure stick to your mind. We are talking about 400 billion encoded token. Okay, so here, right, you get a comparison in figure 4 on your left-hand side of the amount of petaflop per day that was being used to build a particular model. So here you have BERT. BERT was once upon a time a state-of-the-art language model, right? And you have T5 as well. T5 was also once upon a time a state-of-the-art language model. And today, for GPT 375 byte, you also will get tremendous requirement in terms of the number of petaflops operation that needs to be done per day. So we can see that GPT-3, right, at 175 billion parameters is actually a very resource-intensive model. So talking about that, how much resource do we need to spend? So if we were talking about floating point operation, then you need 3.14 to the power of 23. This is the number of petaflops you need. And if we were, right, to run the training for GPT-3 using a V100 Tesla cloud instance, even then it would take you 355 years to accomplish the processing load. And in terms of the memory requirement of GPT-3, it reached up to 700 gigabytes. And finally, if we were to put a dollar value onto the resources that was consumed for creating GPT-3, you are looking at spending close to $5 million for building this particular language model. Now, I hope that by now, all of us here today in this talk will realize that we will not be able to create another GPT-3. It is simply too expensive. It consumes too much resources. Now, what we also need to remember is that the main advantage of GPT-3 is that it has more parameters, more layers. It has higher dimension of data. It has more heads for the self-attention portion. And the batch size is bigger, and you have a smaller learning rate. So 3. All right. So these are the figures that you can get. And now, right, let us examine how GPT-3 works by looking at how GPT-2 works. So if you were to read the original paper by the authors of GPT-3, you'll notice that they wrote in one line or another that the architecture of GPT-3 was largely similar to GPT-2, just that because it's trained on a much larger data set. Therefore, the parameters for GPT-3 is so much bigger than GPT-2. So GPT-2's base architecture is that of stacked decoders, right? Stacked decoders. And pretty much you also have a layer which acts as a mask self-attention layer. And basically, because context of a word is given by its nearby neighbors, here in the mask attention way, information from the right of the position that is being calculated is actually blocked. So in the context of our discussion here, to understand how GPT-3 works, we consider this particular exercise whereby we try to generate a sentence, and we try to do that by just giving sample data. Right. So in this case, we just ask the model to write something. So all we give is a starting token. So because there's only a single token that we pass in, right? There is only a single active path. So what happens is that this token here would actually make its way through the self-attention layer and through all the decoder, and this will then produce a vector. And then in a simplistic manner, the vector will then be scored against all the words that the model knows, and the token that has the highest probability is selected. In this case, it will start with the word the. So in the next picture that you see here, this is where we get an idea of how the masking is done by the mask self-attention. All right, and it basically blocks information from the right of the position that's being calculated. And we move on to the next state. So in this slide over here, you can see that after the starting token has been decided, and after it has gone through this stack of decoders, the word that is most likely to appear is the word the. All right. So this is the scenario here. Then we want to take the output from the prior step, and that will be added to the input sequence for the next prediction. So here, the second path is active. The first path, which has produced the word the, is no longer in use. Every layer would have its own weight or interpretation of the value of the token as it goes through, and those weights will be applied onto the second token, which in this case will end up with thing, right? So the thing. So how do we actually generate that vector? So the token, right? In the example that we have seen, the token is the starting token. It is the word the, it is the word thing. Here, it goes through a process known as token embedding, right? And the embedding size depends on the model. So here you see that it ranges from 768 for the small GTP2 model, and it can go up to 1,600 for the extra large GPT-2 model. Then GPT is built on a vocabulary of only 50,257 words. All right. Now, if you compare that number with GPT-3, whereby it was in the billions, then you get an idea of the size of the embedding matrix. So once you actually have acquired the token embedding, you will then need to get the positional encoding. Now, the positional encoding here, right, represents the order of the word in the sequence to the decoder block. Now, this positional encoding is added to the token and embedding, and this new vector is then sent up into the decoding block. So in this diagram here, you see what happens when we actually send the first token. The first token is a starting token. So this starting token will be embedded with its own token embedding. And it will also acquire the positional encoding, right? So the token encoding plus positional encoding will then yield a new vector here, which is defined by that box with light green field and yellow boxes. So this is the one that goes up through the layers of stack decoder. So as it goes up, right, the thing that you will encounter would be the self-attention process, right? So it will go through the self-attention mask layer before it goes into the feed-forward neural net. And the output of that, one single decoder, would then be passed on to the next decoder. In this case, you get decoder number 2, and it terminates at decoder number 12. So this is the vector that we have gotten originally with the token embedding plus the positional embedding, and it goes through all these different decoder. Now, before we move on, to get the actual prediction or probability of what text will or what token will be chosen, we need to look at the idea of self-attention. Self-attention, right, is actually an attempt to understand context. So here, it tries to understand relevant and associated word that explain the context of a certain word before processing that particular word. So in the example given over here, you have a robot as a text, right? And a robot will be associated with the next higher score, which is 8. So here, right, what happens is that the vector that is passed to the neural network, right, is the sum of the vector for each of the 3 words multiplied by their score. So we have a robot and it, and these vectors are going to be multiplied by their score. So self-attention here, right, actually has 3 vectors. You have the query. Query is a representation of the current word used to score against all the other words. And here we are only concerned about the current token. All right. In this case, in the slide, it will be the word it. Then we have a key vector. These are the label for the word in a particular segment. And this is what will be compared against when you search for a relevant word. Then you have the value. The value are the actual word representation. And once every word has been scored in terms of relevancy, these are the words. The values are the ones that are added up to represent the current word. So what happens is that the query vector here, right? Query number 9, it will be multiplied by the key and it will produce a score. All right, so you can see how you have a score going on. So it and robot, all right, seems to have a high score. And once you actually have that multiplied, right? So you have the value vector. Remember over here, the pink value vector, which represents it. It multiplies by the score of 0.19, all right? And it is then summed up. This will then give us a weighted blend of value. So here in this scenario, when we look at it, right? So when we encounter the word it here would actually have a context of referring to the robot, and it has less context referring to the word and it has even less context when you refer to the word it. Okay, so this is the way in which we get the vector, and we come back to the stack layer of the encoder. So at the very top decoder, you get an output, right? And this is the output vector of the 12th decoder, all right, with a dimension of 768. Now, that one will be multiplied by the token embedding. So we know that there are 50,257 words, and we're going to multiply it by the dimension here, which is 768. So this is the n-dimensional data that you will get. So once the output vector is produced by the top decoder block, right? That is then multiplied by the embedding matrix. And we need to remember that every row in the embedding matrix corresponds to the embedding of a word in the model's vocabulary. So you will get, as a result of that multiplication, you will get a score for each word in the model's vocabulary. So what we can then do now, right, is to simply pick the top or the highest score, all right? So here you may end up with adverb, right? Or maybe not. In this picture, it may be ahus, right? Because the logic is highest. So what we do is to sample a word from the entire list using the score of the probability, right? So we can take a top kth to the 40th element, and the model will then take a look at the 40 words with the highest score, and this will then be decided on, and you will get a final word. In this case, it is the word the, and this is the one that comes out after you have gone through all the different explanation. Okay, so one of the things that you can try to do is to actually run this demo, right? For the interest of time, I'm not going to do that, right? Because I've got another 45 minutes, I think. Yeah, 45 minutes, I think. No, I have less than that. It's already been an hour, I think. Yeah, so I've got another 15 minutes to go. All right, so you can try this website later. You can go to Allen NLP, and this will allow you to actually to try out GPT-2. Okay, so when we consider GPT-3, right? Now that we know how it predicts a word by using the same architecture as GPT-2, you find that for GPT-3, because it wants to do away with the need for large amount of supervised data, it actually tries to achieve its goal by using the concept of zero shot, one shot, or few shot. So in this case, let's say that we were to take a translation task. So if we were to use a zero shot approach, then we do not give any example. So here, what is cheese in French? I don't know, right? GPT-3 is supposed to work that out. Now, however, if we were to do it one shot, it means we give a single example of the task. So here, a sea otter in English is a l'otter de mer. So therefore, what is cheese and in English and what is it in France? And few shot, you give a few example. So this is the three method that GPT-3 tries to work on. Because it is trained on such a large corpus of words, right? It has seen so many words. So it stands to reason that the model is complex enough. Now, in the same paper, GPT-3, right, from 0 shot, 1 shot, and few shot is compared with a fine-tuned model. All right, a fine-tuned model has repeated gradient update, and it has a large corpus of example tasks. Now, in the case of GP3, the idea of large label examples are not there. So what does GPT-3 achieves then? It has achieved what is known as state-of-the-art results, or SOTA. SOTA means that this is the best result achieved for a particular data set. So it's done well for language modeling, for the PEN-PDB dataset. It has also done well for long-range dependency, whereby you want to predict the last word of sentences using the Lambda dataset. It has done well for open domain question answering using a few shot model. It has done well for closed book question answering using the trivia question answering dataset using a few shot approach. And it has also done well in the Winograd schema, a task which determines the relationship between a word and a pronoun. So GPT-3 was also trained for other NLP tasks. For example, picking the best ending to a story, translation, common sense reasoning, reading comprehension, to study a relationship between sentences, arithmetic, unscrambling of word, SAT analogy, right? If butter is to bread, then jam is to, those kind of questions. And also for news article generation. Now, the task for news article generation was quite alarming. When it generated news article and it asked human subject matter expert to determine whether a news article was actually true or not, only 52% of the human evaluators managed to perform that task correctly, which means that GTP3 is good at generating news article, right? It is so good that half the time we may not know that it is written by GTP3. So as good as GTP3 is, what are the limitations? It doesn't do well in text synthesis. Yeah, and in this case, what is text synthesis? It cannot determine if two words are used the same way, or it cannot pick up implication of a sentence. Now, GTP3 is also very bad at bidirectional tasks. Yeah, so when you have a bidirectional task, basically you need to model the joint probability distribution of a corpus, and it either goes forward or backward, condition on the word before or after the token. So because it is not bidirectional, GTP3 does not do well there. And in terms of sample efficiency, GTP3 needs to see or train massive amount of text, right? So as a model, it consumes a lot of resources. And the size of GTP3, right, is too big for practical use. Yeah. To load it, you need 700 gigabytes of data into memory. So who has 700 gigabytes worth of memory? And GTP3 is not an easy model to interpret or understand, right? So if we talk about explainable machine learning, GTP3 is not one of the more explainable ones. So what are some of the greater challenges? So GTP3 can be misused. It can misuse to do all sort of things. And because it can generate text, it can generate spam article, it can do phishing, it can write your research paper, it can generate fake news, propaganda, and GTP3, unfortunately, reflect gender bias, racial bias, and religious bias because those biases are present in the text that it was trained on. Then finally, GTP3 consumes many kilowatts of energy to actually train. So it is not cheap, nor is it energy efficient. So here we have a few examples of interesting GTP3 application. So I hope the screen is clear for you. So this is Python 3.8. And here you just type in the code and it will tell you what is the code that can be generated. All right, so this is a code explainer, right? So it can already explain the code that it sees, all right? So I'm thinking if I had this in my tutorial room, then my life will be very easy. I just pass this tool to my students and then they can just interpret the code without me, all right? But then the question is, what is my function in that room then? Okay, next is you can create, right, a JSX layout. And JSX is actually a UI. So here you just type in the command and out comes the user interface element. All right. So that's pretty nice. You don't have to type in JSX anymore, right? JSX here looks like a bit like HTML. Then you have English to regex. I'm sure you have all tried regular expression, and sometimes it is very hard to get the correct regular expression. So for example here, find a valid URL that starts with HTTP or HTTPS. So you provide a string and then you click generate and the regex text will come out, all right? So this is really a very good implementation of GTP3. So moving on, you will also have different application, which you can take a look once I share the slide. Down to my last 5 minutes or so. So I'm not going to show everything. So you can use words to generate website. You can use words to generate charts. All right. You can also use GPT-3 to power a text adventure game. All right. So traditional text adventure game, right, requires a lot of script and pre-content to be written. However, for GPT-3, it just uses GPT-3 to keep generating text content. All right, so this is quite nice. So how do you get started with GTP3, right? you can get an API key by joining the wait list, and then you can then go to Sri Shankar's sandbox, put in your open API key, and then you can start to put in example pairs, and it will generate text for you. If, however, the waiting list is too long and you want to do something now, perhaps you can actually just try GTP2, right? In terms of architecture, it is similar. It is just trained using lesser parameters, and perhaps it's not as powerful as GTP3. Okay, so these are all the references. So brown is the original paper for GTP3. That YouTube that you see on screen, it explains the brown paper. Then you have some write-up by Lambda Labs. Then you have Redford, who last year came out with GPT-2. Then you have Sri Shankar's sandbox. And that's it. And that's the end of my presentation. So yeah, we are looking for postgraduate students. If you are thinking of furthering your studies at Sunway, drop me or my boss an email, and I'll be happy to take your application and see how we can move forward. Okay, Dr. Naresh, can I stop sharing my screen now?
Yes, sir. Yes, sir.
Okay,
sir,
thank you.
Thank you so much, sir. That was really an amazing space, sir. And thank you, sir, for sharing your great knowledge with us. Sir, we have some questions. Now I want to present a question, sir.
Okay, yes. Please go ahead with the question.
Yes, sir. Sir, is it visible?
Yes, it is visible now.
Okay, sir. Yes, please.
Okay, so when we talk about spurious correlation, right? So when the model becomes more expressive, it then begins to pick up correlation that are existing because of the frequency of the token, right? For example, you may have certain biasness against a people group, right? So people group X are often described in the corpus as exhibiting a negative trait. So, as the model becomes more expressive, this kind of correlation will become more and more common. For GPT-3, you do not need a GPU core, all right? In fact, it is using, you don't really need GPU core, but GPU core would actually speed it up because it's a decoder, yeah, and it will speed things up. But then we all know that you can run deep learning stuff with just a CPU. Okay. Okay, GPT would be actually, in this case, is very unsupervised actually, because we are talking about the application of it. When you use GPT, is you don't even need to give a train example. It is capable of doing 0-shot, 1-shot, few-shot machine learning. So it's quite unsupervised. Of course, to come up with the GPT model, to produce the model itself, then you have to learn from a large corpus of text. Okay, for Dr. Dilip's question, commoditization of search engine for GPT-3 and SEO. I guess search engine will become smarter. So when you type things into the search engine, if it has been trained on GPT, then it will be able to very quickly figure out what is the search phrase, and then maybe do a look ahead and try to optimize the search result. Okay, what type of, Dr. Boss question, what type of application do you think GPT-3 will be most suited for? Definitely, it will be in the realm of text generation. Already, we can see that potentially it can replace newspaper or journalists, right? If it's not a very factual article, it will complement story writers, yeah, and we have seen how it can also help in education. You can generate your own test bank. You can help students understand programming language. But by and far, I think GPT-3 would really change how text content is being dealt with, especially those that are not very creative, material that we have seen that do not change much over time. Those are very good to be produced by GTP3. Can parameters be reduced? Definitely. Yeah. I think the version of GPT-3 that you get using the free API, it will not have, it's not that huge version. And what factors should we consider while reducing the parameter? It's always a trade-off between the size of the model and also the accuracy of the NLP task that you want to consider, right? You reduce parameters, then it is less effective. Can we use GPT-3 in image processing? Short answer is yes. If yes, how? I cannot give you an answer on how, but I have seen papers out there that describe the usage of GPT-2 for image processing. Yeah, so if we were to consider how we know GPT works, right, then I suppose if we were to take the idea of a token, and if we were to consider the token as, I don't know, a pixel or some form of convolution unit, perhaps from then on, if you replace the idea of a text token with an equivalent graphical representation, and then you put it through the decoders, perhaps you'll be able to do generation of images, maybe. But this is me really just thinking off the top of my head. You probably need to read up the paper on how GPT-2 can actually be used for image processing. Okay, I hope I've answered the questions all right. Yeah.
Yes, sir. Yes, sir. Thank you, sir. Thank you for your nice explanation. And
thank you, sir.
Once again, I want to thank you, sir. Sir, we're looking forward for your same support in future event as well, sir.
Okay, thank you, Dr. Malaya.
Thank you so much, sir. Thank you.
Okay. All right. Thank you, everyone. Enjoy the rest of the conference.
Thank you, sir. Thank you. See you.
Thank you, sir. Participants, now we can have a break for 5 minutes. We'll assemble here after 5 minutes. Thank you so much.
Dr. Naresh, I will send you the PowerPoint via Gmail. Okay, all right, I'll send it to you shortly. And okay, thank you for the invitation. Really quite fascinating to do one of these webinars, and it's also personally nice to see you again.
Thank you so much, sir.
Okay, Dr. Malaya, thank you for having me.
Sir, namaskar, sir.
Okay, so please do keep in touch. All right, I've got to go off now. All right, I've got to attend to something, but it has been an interesting time. So thank you, everyone, and have a good day. Okay, all right, bye-bye. Okay. All right. See you. One day soon. Yeah. Bye-bye.
Yes, sir. Sir, sir.
Good morning, Naresh. How are things in Silchar? Tell me, how are things there? Managing somehow, right? Yeah. So, when is your semester starting with the students? Already you have started, huh? Very good. Actually, today we have our on as of now. Okay, right. Okay, good.
Yes. Welcome back to the second session of Day 3 MLCV 2020. Now, let us have the pleasure of listening to our honorable and great speaker, Professor P.K. Das sir. It is my privilege to introduce Professor P.K. Das sir. It is my privilege to introduce Professor P.K. Das sir. Professor P.K. Das is working as professor in the Department of Computer Science and Engineering, IIT Guwahati. His research interest includes speech processing, mobile robotics, server physical systems, software engineering, algorithm, and smart devices. Sir has completed 15 research projects in the above areas sponsored by CSIR, Department of Electronics, Indo-US Sponsored Project, Ministry of Human Resource Development, Ministry of Information Technology, CDEC Kolkata, Ministry of Social Justice and Empowerment, Department of Information Technology, Ministry of Communication and Information Technology, Ministry of Human Resource Development, under National Mission Education for ICT, Government of India, and many more. Apart from the research publications in journal and conferences of review, SAR has also been associated with development of National Program for Technology Enhanced Learning, NPTEL, web-based course, namely Data Structure and Program Methodology. Now, may I request you, sir, to kindly start your presentation. Sir, kindly.
Thank you. Thank you, Dr. Malaya, for a lovely introduction. I will just share my screen. Please confirm if it is visible.
Yes, sir. Yes, sir. It is visible, sir.
Please check if it is visible.
Yes, sir.
Yeah. Good morning to all my virtual participants. So we meet virtually today, and today we will be talking about machine vision analysis. That means what machine sees and understands versus human vision understanding. What as a human being, what do you understand from a scene, from a picture, so to say? And so we'll be looking at some of the issues that are there and some challenges which we need to address. Okay, so with this very simple, rather cryptic, title, let me start the presentation. I will try to keep this talk as non-mathematical as possible, and rather it will be more of an interactive session where I would like all of you to participate and be a part of a few experiments which will happen. And remember, you are the person who will conduct the experiment. Okay, so with these few thoughts, let us start the presentation. So the first slide that you see here, you can see that this is a screenshot of a Google map. Okay, so a Google map application has provided me this screenshot, and the moment you see this particular screen, okay, a picture, so to say, what do you get to understand? You understand that if you are living close by to this area, maybe Bangladesh, maybe India, part of it, maybe Myanmar, maybe Assam, then you immediately converge and say that, well, this is where I live. This is my place. It's a map. What's the big deal in it? Now, the moment you do this, you did not take the liberty of finding out the algorithm to actually converge to this decision. Did you? Answer probably. You said, what's the big deal? I know this is a map. I've been looking at it. I've seen it before. It's there in my mobile or it's there on my desktop. I use it all the time. Or some of you may not be very familiar with this place. You will start looking at the keywords, West Bengal, Jharkhand, Bangladesh, Patna. And you will say, wait, I know something about this. So you will get a decision on this. So this should get your grace scale, cells sort of exercised, that we have seen something which is useful, partly useful to you. So I'm taking you to the next picture now, the next photograph, which is something which not all of us would know, but some of us would know. So what is this? You can use the chat box. I guess there's a chat box, and quickly type. I would like to see how many responses I get to see. What is this place? How quickly can you do it? Let's see. How fast can you quickly write a few lines? At least 1 or 2 words. Which place is this? Can we get to see something? I'm waiting.
Yes,
So
sir.
what we see here is that this again is a map which is highly amplified, and there is a river flowing through that particular image, where you can get to see the actual text, which is Brahmaputra River, and you can see the campus of IIT Guwahati on the north bank, and a part of the city, which is Guwahati city, which is on the south bank. So what we can see here basically is a map of IIT Guwahati with the river and a bit of the Guwahati city. So this is again for many of you, or some of you, it is sort of visible. You can immediately take a call. I know which place this is. For those who are not familiar, it's new information for you. But somehow you had stored this information somewhere else so that you could possibly converge. Tomorrow, if I show you this image, it may not be so difficult for you to immediately converge and say this is the actual place, this is the actual area. Okay. Moving ahead. Now, if I take picture, if you see carefully, is an amplified picture of the campus itself. Now, for a person who is living inside the campus, they would love to see every nitty-gritty details about this place and would like to know what construction is going on, what is happening, and things like that. Okay, so this shows that with just 3 pictures, 3 images, I am able to weave a story out of it. Is it clear? All of you understood? With just 3 images of Google Map, starting off from a top level view to a mid level view and slightly more low level view kind of thing, we're able to store, we are able to put a lot of information there and give you some information there. Okay, so moving ahead, I'm going to show you 6 photographs. Can you see the 6 photographs on the screen?
Yes, sir.
Good. So on the left hand side, top one is the IIT Guwahati campus when it started. Okay, way back in 1998, these buildings, the small tin roof buildings, had come up, and this is how IIT Guwahati started. I had the fortunate memories of joining at that time when I took the first class and the first lab of CSC department. In this particular transit complex, as we called it. Okay, now it's called the technology complex these days. Most of the startups are coming up here. Okay, and many other things. So this place starts, is the starting part of IIT Guwahati. And over a period of few years, you can see the playfields are being developed, the stadium facilities are coming up. You can see the river in the background, the Brahmaputra River, and slowly the academic complex taking shape, residential quarters coming up out here, as you can see. Then our auditorium, a massive auditorium of approximately 1,500 people. Okay, a mini auditorium in front, and so many other facilities. Okay, with conference facilities beside it. Okay, and then of course the nightlife, as you can see, which looks like a mini city now. Okay, so these photographs put together put approximately 25 years of history on a single canvas. So I talked so much about coming up of an IIT, starting from just a tin roof building all the way up to a massive, a mini city, so to say, with most of the facilities in-house. Okay, so this whole story is stitched up in just 6 photographs. So this shows that an image can contain huge amount of information. You can actually, store a complete story inside it, and you can elaborate it like anything based on just a few sequences of photographs. No more, no dynamic content at all, only photographs. Now the big question here is that, can I make an automata do this work? A tough question. Can I make a machine or an automata which would possibly do this work? Is it possible? Now let us try to address how a human being uses their eyes, and how possibly a machine, if designed properly, should use its sensors. So these are the things that we will discuss today, and we'll try to appreciate how a human being works and what qualities should be there in an automata, in a machine, the algorithms that go in, so that it works or tries at least to imitate a human being. Okay, so moving ahead, so we say that a picture is worth 100 words. Now this is a very famous saying. I just clipped it from somewhere. Okay, so I'm not giving credit to anyone here. Okay, but then just look at this particular picture carefully, and you have to answer a few questions. There is a saying that success is like an iceberg, and people see this. And look at this picture very carefully. You can see an iceberg, and there is some text here. People see this, and we see success or a shield or a cup or some gift or a prize being given. That's it. Now the question is this the complete picture? What is going in your mind? What is the next slide? Any ideas? So in your inner mind, with approximately 25-30 years of your being in existence on this planet, knowing the language English, you will be cooking up some probable answers. Now, can I get one or two answers from you? Maybe they will be funny answers, they may be perfect answers, they may be anything. So success is an iceberg, so you get a clue. If there is an iceberg, there is ice here. There'll be more ice somewhere else, beneath the water. So let us look at the remaining part of the picture and try to make this complete. Can you see the complete image now? Yes? So now,
Yes, sir.
now you see that showing you the previous image, this may be the input to the system. Can you possibly make something, some machine, some algorithm, which will give you approximately what this is? Because in your mind, you already knew that you only know this is the tip of the iceberg. We always say that there's a saying. So those who are familiar with saying that this is the tip of an iceberg, there will be a lot of ice in the under the water, which will have the buoyancy and it will push that part of the ice up. The iceberg will be on top. A lot of ice will be beneath the water. So the qualities which are going to be there, success is what you get, but you need to take risks. You have to have good focus. You have to have your goals clear. You need to have good amount of persistence. You have to be very, very, what you call it, persistent, or you have to be very, very, grudgy in terms of getting to your goal. You need to look at failures. Don't get upset. You need to have a lot of action in place. You have to work very hard. You have to look into sacrifices. You would like to play some games, you can't play. You need to go out and have a picnic. You can't do that. You have to work for it. You need to develop your habits, and you need a lot of hard work to be done. So all these things put together will give you success. People only get to see the great card, as you may call it, but what goes inside is a lot more. Okay, so this is a complete picture telling you the whole story about how to succeed. So one image, you see a tip of the iceberg here. What goes below it, if it is not shown, If this part of the image is not shown, can you possibly predict it? What does it take? Whatever resources you want, you can use it. But can you get down to saying approximately that this is what my system will give as an output? So this is what a human being does without any issues. And if the person is well read, has done a lot of proper schooling, very sincere, no issues. Immediately, the answer will come within milliseconds. Won't even have to think a lot. But for a machine has to, the automator has to actually do a lot of hard work to come to a solution like this. Okay? So this is what we can say, that a picture is worth a lot, 100 words. Let us look at the next example. This is a lot more complicated. I hope all of you can see this image carefully. Take your time. Try to read what is there on top of the table. I hope you can read it. I have reduced the resolution of the screen so that it's readable from my side. So can you possibly read what is there on the table? It is written table. If you see on the chair, you will see it is written chair. If you see on the chair on this side, it's written chair. If you see on the wall, it's written wall. If you see on this particular side, you will see it's written border, B-O-R-D-E-R. So whatever is the material, it's written tapestry out here, okay? On this side on the wall, you'll see it's written tapestry. So with the words, the objects are generated. Pretty neat, right? If you see carefully, it's written leg, the leg of the chair, it's written LEG, LEG, LEG all the way. So with the characters, with the words, the complete picture is generated. Now, what does it take to make this kind of a image? So if I tell you that make photograph with these qualities, with these objects inside, can you possibly use the text to actually generate this particular image? It's quite tough. So with words, with thousands of words, you have so this again gives you an example that we can possibly, curtains are there, doors are there, so many, so door is written out here, so many things are there, okay? So this is how you can generate or get a lot of information from a given image. Now let us look at this picture carefully and try to understand the content of this picture from a human perspective. It's very important to understand that what you think is important. Don't worry about algorithms, we'll come to them. Algorithms will only make sense if you know what you are doing. If you don't know what you are doing, it has no sense at all. Okay, you are much more higher than an algorithm. Okay, so let us look at this particular picture. Can you see this picture? Maybe you can quickly type or you can just say.
Yes,
Is it
Yes,
visible?
sir.
So does it look
Yes, sir.
like something you have seen before, sometime in the past? This looks more like like an animal,
Yes, sir. It's
like
look
a
like
Yeah.
like a kitten or a cub. Okay, looks more like a cub or a kitten. But then if you look very closely, you will know that this is not a cub. Basically, these are clouds. This is basically a bunch of clouds. And by hook or by crook or natural phenomena, it took the shape which seems familiar to you, and hence you can actually see a cub. You may smile and say, wow, I mean, whoever took the picture had good eyes. So from an aircraft possibly. They took a picture out here. So this shows that your mind, your brain is capable of extrapolating a lot to figure out impossible things and give a meaning to it. You are able to give a meaning to something which is cloud, but this is not cloud for you right now. This is actually a cub or a kitten, okay, or something like that, okay, a small cat or something like that, okay. But then, of course, after some time, you will say, no, 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 no. This will change after some time. Once the perspective changes, or after some wind or breeze, things will be different. It won't remain for long, okay. So let us look at the next example, which is a pretty amazing example, and try to appreciate what, as a human being, you will say about it. Now, if you see this particular picture, it's a picture of the sun, a sunset, but below the sunset, you can see something amazing. You can see possibly the face of a lady etched out in a cloud formation. And you can actually find this. This is not a fake video or fake picture. This actually happened somewhere in Greece or somewhere. Okay, you can find out. I put the link below the picture. And you, as a human being, would immediately latch on and say that, wow, what a natural phenomenon. I can see a lady in the cloud. There's a lady or a girl, that image is there, of the face is there. So can you make an algorithm which will actually converge and tell you that there is a sun and there is a below the sun? You can articulate and you can annotate and say that there is a picture of a lady. And if you are smart, you can say, well, who is that lady? That's it. You can even do a bit of recognition on this. So can we come up to a algorithm which will do this? Tough one. As a human being, no big deal. Now let us try to understand why you could do this and why a program or algorithm, generating an algorithm is so difficult. So let us look at the next slide, the last one. This is also pretty funny but nice. Can you make out what this is? This looks more like a rabbit or so. Again, a
Yes,
picture
sir.
taken from an aircraft, and I sometimes make a collection of these, and then I found that there are many people who do the same thing, and I'm going to give you a link where hundreds of such beautiful cloud formations are there, which has some physical significance to you as a human being. So this is a pretty nice one. A rabbit looks like a rabbit. This is a cloud formation, and you can check out this Pinterest, and there you will find amazing shapes in clouds. Now the question is, now let us come back to ground truth or reality, how to make an algorithm which will possibly say that this shape or this input that you provide as an image looks like a dog or a cat or a rabbit or a human being or whatever it is. It's not an easy one. You would say, let us do some neural networks, let us do some deep learning, let us do something, and it will work. As a human being, let us try to find out how it works. Then we will come to the machine domain. Okay? So let us first summarize what we have looked at till now. The first thing which we have looked at is that human vision can do amazing things. It can recognize people and objects out of almost impossible things. Cloud formations which are very dynamic. Lighting changes which allow a person to converge and say that this is an object, not a cloud, something else. You can just think about it. We are capable of navigating through obstacles. You don't really keep touching all the things and then you move. You just look at a particular place and you start walking. So we can navigate through obstacles pretty well. You try to make a robot, go over a particular obstacle or go around a particular obstacle. It's almost a nightmare. You have to think about so many things, and even then you are never sure whether it will work or not. We are capable as human beings. We are capable to understand the mood in a scene, the sense in a scene, the secondary or the higher level abstract content in a particular image. A machine cannot do that. Okay, and we are capable of imagining and formulating stories out of a picture. As a school teacher, some teacher must have told you something. Don't tell me stories. I know what you are thinking. So the teacher has probably thought ahead of you, maybe 2 to 3 steps, and knows what is the next answer that you will put. So the teacher doesn't want all that answer. So the teacher says, don't tell me all these stories. That's a very common one, actually. Most of you have heard it, including me. Okay. So we are capable of thinking ahead by taking an input, just a simple image or a text or probably a bit of speech or something like that. So can a machine do this? Can we possibly do this? So let us look at what a human being can do. We can do all this, but then we can't do everything. But we are not perfect. We have got issues with our vision. So let us look at what those issues are and possibly how to correct them quickly. And we can use automata for this now. We suffer from illusions. Now, how many of you believe in ghosts? Many of you would believe in ghosts. Some of you rather would believe in ghosts. I would like to switch off the whole power supply of a particular building, and I would like to see people jumping around and said, "Oh my God, what will happen to me?" Okay, jokes apart. But then, yes, we are scared if something unusual happens, and your eyes are tricked, or your sense of hearing is tricked, and you are not supposed to hear water, but you tend to hear water in a room where there is no water. You will be worried. No, I don't think there is water in this room. How come there is a sound of water in this room? Or something's moving around in this room where there is nothing, there's nobody in that room. No living beings are there. So you will be worried. So we do suffer from illusions. We also tend to ignore many details in the picture. Now let us look at the slide. You please look very closely to the slide. Look at the slide carefully. When you look at this slide, this particular slide I'm projecting, you can see human vision. Did you care to find out the font size of the H character, the first character H, human? Or did you start looking at the left topmost pixel and try to find out if the brightness level is the same as the one which is in the middle of the screen? No. We were very, very happy with it. Is it fine? I mean, chalta hai. I mean, I'm more than happy with this. Okay, I'm good. Human vision looks good to me. Let's go ahead. I mean, fine. But when you give this input to a computer, to an algorithm, the poor algorithm will start analyzing every pixel with equal weightage, right from the top leftmost pixel all the way to the bottom rightmost pixel, and then start scratching its head and trying to find out what is important there, what is not so important there, how to remove the unimportant ones. Okay, unimportant pixels, what are the relationships inside the picture, is there text inside or an image inside, or what is inside, then find out, do some detection there, and then do a lot of hard work to find out that there are just few characters in this particular image. So we tend to ignore many details for our benefit, but unfortunately, a computer doesn't. So the bottom line here is that we may suffer from illusions. A program will not suffer from illusions. Okay? If you make a robot, the robot will not have problems of illusions. It will do the job unbiasedly. We tend to ignore lots of details to our benefit. We don't do a lot of analysis, but a machine will analyze everything. So that goes as a disadvantage now for a machine also. You don't want it to analyze every pixel, or if there is some sand or a piece of dust on the screen, that will be taken as a dark pixel, whereas it's absolutely fine. You can ignore it. No problems. You will have several scratches on your screen. Do you tend to look at the scratches all the time? The answer is no. Are jane do, you will say, forget it. Fine, I'm fine with this light. So, but a machine will not do that. So there are issues. We normally have an ambiguous or uncertain description of the world. It's not a full-fledged description of the world. We really don't care if it's a rectangle or a square. Can you possibly draw a perfect circle on a screen? I would like to do it. Like here, I'll try to do this very soon. Let me try it. This is just fun. This is the best I can do here. My God, it doesn't look like a circle at all. Okay. But then all of you would be more than happy. You will accommodate and say, sir can do this at best. You can't do any better than that. Because I also can't do any better than this. So you'll be happy with it. So this is also acceptable to humans, but it is not acceptable to a machine. Okay, so we live with it, no issues at all. Okay, sorry, just a moment. Let me quickly come to the slide. Right. So coming to the slide, we also don't care about the accuracy of the details. So when I actually project this on the screen, I'm more than happy with the resolution that is there. But then fortunately for me, I have a massive screen right beside my laptop, which will eat up all the bandwidth if I try to project from here. And it will show everything very, very neatly, and all the colors are very bright and all that. But then I don't care. I just need what I require. But if I do some very fine work, I need a very high quality monitor. But as a human being, you are just happy with what is there. If it is a dark room, you don't really need a lot of light. You will say, manage, I'll manage, no problem. But a machine cannot handle that. Okay, so it sort of works. Okay, we are not so accurate in our work. Okay, so let us quickly experiment with ourselves and look at the next image with a lot of, effort. Please put sufficient effort in this so that you enjoy and you also understand how a human being analyze a scene and how a machine possibly would analyze the same scene. Okay, so look at this particular picture very carefully. Okay, look carefully. I put another slide on this. Okay, here we go. So what I'll show you here is these are two cement blocks which are lying on the field in a sunny day. Okay, so you can see a blue sky beneath behind the two cement blocks that are there, and one block is on top and there is another block at the bottom, and the sun is on top. Of course, you know that it's midday possibly, and a picture is taken, a photograph is taken. So all of you can see this particular image neat and clear. Yes, looks good. Okay, good. So now once you see this image, I pose a question to you. Very carefully analyze this image, see this image carefully, and try to find out that if I draw up a small box here or a small ellipse here and a small ellipse here, are the two colors of this part and this part, are they same or they are different? So what is your reaction to this? So I would like to know if the color of this gray is the same as the color of this particular gray. Are they two same or they are different? Approximately. You can't be too accurate. We are all human beings. So are they the same or they are different? You make a decision right away and you write it on a piece of paper. You say yes or you say no. You don't say maybe. Okay, this is not cricket. Okay, you have to say yes. You have to say no. That's it. It's your call. You just have to say that. Okay. So once you write down the answer, I'll give you about 5 seconds. Write down the answer. That's it. Don't change your answer. You look at it carefully and take a call. Write down the answer. Done. All of you have done it, I guess. Now, I'm going to show you the next image very carefully. Well, I'm showing you two blocks. Two blocks. Are they same? They look same. At least as a human being, I would say they look pretty same. Now what I'm going to do is very interesting. This block looks pretty similar to this block. So I'm going to close this particular slide and I'm going to simply remove some pieces from the side of this particular image. So what do you see now? Can you see the original image? So your initial reaction as a human being, if it was no, you have been fooled, so to say. Your eyes have been fooled. So it is actually the original image. I'm just going to do a Control Z or a undo option, and I'm going to recreate these images for you. So these two are actually same. But then your eyes got foxed, okay, because of the content of the surroundings. You would not have this issue if I showed this to you in the first place. But then you did have this issue of saying that they are different because I presented to you this complete image. Is it clear to all of you now? So what is happening here is that this particular image, you correlated, very important, you correlated with real life phenomena. And your real life phenomena is there is a light source, which is the sun. There is a shadow which you can see. There are very bright parts and there are very dark parts, which is correlating with shadows. You can see the blue sky and you can see the ground. And hence, you would expect that this would be brighter than this part because the sun is shining straight on top of this. But then, in reality, we find that this is the situation. Okay? Is it clear to all of you? So this is actually an illusion which has happened to you because of our extra knowledge of being a human being for so long. Hence, even if the grayscale values which are there are almost same, if you take the average grayscale values of these two blocks, you'll find they are almost identical. Still then, you do not want to converge and say that, these two blocks are different. Pretty interesting, isn't it? So all of you have enjoyed this? Is it fine? Got it? So let us go to the next slide. So now the takeaway from here is that you can be fooled. So given that you have a lot of extra information, you can be fooled, but a machine will not be fooled here. The machine gives the two blocks to an input system, the system will figure it out. He said, this is for good. These are two similar blocks. But then as a human being, since you have more information, we can be fooled. Okay. So let us look at, so why is that happening? You should now know that I had a lot of extra information which I used and I got foxed in that. I got, trapped in that. So if you're going to make an automata, please remember, if you want to make a machine now, you have to put in just the right dose of, ground truth and also the environment and also the domain information. Don't put too much of it. If you put too much of it, you might run into issues. It knows too much, then it might run into problems. So this is, of course, one part which you can look into. Most of the time, of course, we don't put enough information. That is the problem. Or most of the modeling problems are not fully defined. Okay. So let us look at any other, examples that are there. So I'm going to show you another example, another test, so to say. All of you try to look at it. Interesting. So keep a very close look. I don't want to fool you again, but I hope you will not be fooled again. There is no fooling business out here. So let us look at it. So look at the image for about 10 to 20 seconds sharp, very sharp. Look at it, and then I'm going to change the image all the way. Okay? Look at the image. What does it look like? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I'm going back. It looks like, you can type it out in your text chatbot or something like that. Looks like a human being, a man. Yes or no? Correct? It looks like a man who's sort of looking at you, peering at you, literally looking at you. But then, look closely. There seems to be other scratches here and there. Can you see the small scratches here and there? Yes, you can. So if I look closely and I give you a close-up of this particular photograph, it's basically a painting, hand-painted. Now you can see there are many objects rather than a single object which was a photograph or a painting of a person, a human being. So can you make out the different objects that are there inside this particular painting? There are two eyes are now substituted with two huts. And two huts, you can see the original hut out here, and there is a boy who is sort of painting, sitting here and painting the same hut. There are trees around, There is a box out here. There's a bag out here. There's a proper, canvas out here. And so many objects are there, grass and things like that, cloud, birds, and so on and so forth. So what do you understand from this particular image? So many objects are there, stitched together in a proper format, gives you what? Gives you a human being, gives you a face. That's it. Now try to imagine that if I take a photograph of this particular image and present it to a system, and I want to know what objects are there, can I, number one, get the first answer as a human being? The second answer as there are so many objects that are there. There is a human being inside this particular thing. There are trees, there is a bag, there is a box, there are huts, there is a canvas, somebody is painting. Can you annotate all of these guys from this particular image? This is a fun. So try to appreciate whoever drew this particular painting. I have sort of got it from the internet. Imagine the amount of effort the person actually thought of before painting this particular picture. It did not just come up on its own. The person actually concluded the whole thing, thought the whole thing up, planned it out, and then with brush strokes and color made the whole thing. This is big work. This is really good work. Okay, it's a difficult work to do, and the person actually made it finally. So can you make an algorithm which will detect all these objects? So I will take another example, and then I will come to the issues and the challenges that are there when you handle these kind of images in your image processing algorithms. Okay, so have a look at another image, which again is a small image. Now you are much more smarter. You will look closely, and with this image itself, you will try to find out some objects that are there. So I'm giving you approximately 10 seconds. Think about it. You may write down the objects that are visible. This looks like a person who is wearing, an old man or something, wearing a mask, medieval age or something like that. But when you come closer to this particular image, this particular painting, once again, you find that there are many objects which are familiar to you, which are there in this particular image. So you can see there are horses, not one horse, but there are two horses out here. And there are so many other persons, soldiers that are there. Putting all of it together, you get a person who is wearing a mask. So this again shows that one image, looking at it from a particular perspective, a close-up of that can reveal many things. So what do we learn from this? These are pretty interesting things to look at on the face of it. But what is the main learning from this? The learning here is that when you make algorithms for robots or for objects which move, you should not do object recognition. You should never, let us look at the negative side, you should never do object recognition with just one image. Try several images of the same object, possibly from different cameras, or move the object back and forth until you have several analyses done, and then find out which one works better for you. Is the idea clear to all of you? So with a very trivial or a rather tricky example, I'm trying to impress upon you that do not do an analysis with just one image. Don't start off with this image itself, because it's not going to be so easy. Because there are so many objects, so many complicated things that are there. How possibly will you make out? So a holistic look or a quick look or a first level look would be this. So as you keep amplifying this image, you will start getting the other objects which are there in the image itself. So this gives you a good clue how to go about it. Okay. So have all of you understood this layout now? Fine. So let us move ahead now. So what do we learn from this? So I have just summarized it in a single line, that there is an element distance that biases our decisions. So the first decision may be different, but once the distance between the object and the camera or the object and the person is changed, it may change the decision altogether. Or you might converge and say, this is it, I don't want to change my decision. Or there may be many different, solutions that might come up. So you should try to look into these aspects. Okay, right. So now I'm going to show you some trivial stuff, and I hope the students and faculty from NIT Silchar would be able to recognize this image. So I have put the name as the door. It's not the Doors, the group the Doors, okay? The singing group, the Doors. It's the door. Why I have written the door is interesting. Look carefully. Whenever you cross from one room to another room in your own house, going outside the house, or inside an institute, going from one hall to another hall, or going from one room to another room, you have a tendency of looking at the bottom of the, looking at the floor at the junction where the door is. And when you look at the door, you get to see something like this. So can you make out the bottom picture, the NIT Silchar people? Does this look familiar to you? Yes or no? I would like to get some answers. Can you recognize if you have seen this before somewhere? Maybe you have. Maybe you have not noticed, you have not registered it so much. Maybe you have. So I have put together two. This is another institute, it's another university. And this is, of course, NIT Silchar. Let me tell you, this is our the seminar room which is there. So I took a picture of the doormat and the seminar room. Okay, long back, of course. So you should recollect, of course, most of you are online, not visiting the institute. So this is a recollection of your institute itself. Okay, so jokes apart, you can see the small bar or a marble, small bar that is there on the door. Why is it there? Can you make a guess? Why has this been put? It has been put to ensure that if there is a rain, a lot of rain comes through the corridor and all, it doesn't get inside the room. Or the room is reasonably clean from dust, so dust particles won't go in once the door is closed. That's the purpose of putting this bar. So you will find that most of Indian households will have a raised bar like this at the doorstep. Mostly when you are going outside the house or the back door to the garden or something like that. So when you were a child, your parents must have told you several times that be careful when you go outside the house. Watch your step, otherwise you would trip. And most likely, as a child, as a small toddler, okay, few years old, 2-3 years old, you know how to walk. You would never listen to your parents and you would trip and you will fall down. The first time you fall down, you don't know what happened. You start crying. You got hurt. Your parents will come running, lift you up and say, see, I told you, don't do this. You have to look at the door and then go. I can't change the door for you. You have to be careful. The second time you do this, again you get hurt. You start crying. And then you say, okay, fine. There is something in this door because of which I get hurt. I got to be a bit more careful, but I don't know how to be careful. So you start correlating the speech of your parents after your fall with the amount of hurt, the pain that you get from your legs or your arms, whatever it is, hopefully not your head, okay? And you start correlating this patch, this particular bar to getting hurt. And none of us want to get hurt. So over a period of time, 4-5 times your parents would say, then they'll be busy with their work. And you will become wiser and you will slowly lift your leg over this bar and you will go safely across and you will immediately justify your claim that I should lift my leg and go. What my parents told was the cardinal truth and I should be careful. And if a friend comes to your house, you will tell your friend, oh, don't do this, you will get hurt. You will also tell your friend that, this is a tricky business. You have to lift your foot and go. And that remains in your head till your dying day. You memorize this and it remains at the back of your mind. You tell it or don't tell it, but you have memorized it, and it remains in your system. So anywhere you go, if there is a door, inherently your eyes will go to the bottom and have a quick cursory look if there is a bar like this. Otherwise, you might trip and fall and make a fool out of yourself. Okay, and people will laugh at you. You don't want to do, or you might get very badly hurt. You don't want to do that. You want to be safe. Okay, so this is the clue that you get, that you are using your eyes to keep yourself from any kind of bodily harm. You want to survive, right? You don't want to get hurt. Now, how possibly will you make a robot learn this? Now comes the computer science perspective. How possibly to make a robot go over this particular, or rather go around, don't cross over, or go over this in a particular way? You can't use the same algorithm to, just run on top of that particular bar. How would you do this? So if you do not give any proper instructions, it will go and hit, and the robot might be damaged. But if there are enough sensors there, the robot has to learn over a period of time how not to get hurt. You cannot always tend to it all the time. So the first 2-3 times it hits, you have to have the algorithm remake itself to say that don't do it. It's not a good idea. Or you have to have another sub-algorithm which will handle such cases. It's like exception handling. You do this in Java all the time. Okay? You write exception codes. So how would you do this for, taking an input as an image for a given robot to do the path planning? Think about it. So remember, the door effectively means that you must have several developing or self-developing algorithms which will handle such cases. Is it clear to all of you? With an example I have shown, a real life example, you will get several such examples in the lab. Many a time I can say that I can use deep learning methods to do it, but I have not quantified the problem at all. Here I have quantified the problem. So there will be several such problems. You need to quantify them nice and properly. Then the system will survive by learning over a period of time. Is it clear to all of you? Fine. Okay, so let's move ahead. So we infer from this the following, that we need to know about the domain over a period of time. You can't do this in one stroke. Some big brother handling is required, some handling is needed, but the system has to develop and then handle such boundary or corner cases, or difficult exception cases. Okay, right. Now let us look at something a bit more funny, interesting also. I hope I have not bored you too much. So let's look at this carefully. Now the mood of a scene. By looking at a particular image, what we want from it, what do we learn from it? We also have our psychological balance adjusted by looking at this image. Now look at this particular image and tell me what you get to see here. Now I have written on top, please see the next slide carefully, I have uploaded it. A sad dog. Yes? How many of you would agree that this is a sad dog? By looking at this image, would you agree that this dog looks sad? Right? Yes or no? Looks
Yes,
sad?
sir.
Looks sad, right? So mostly, most likely, it looks like a sad dog. Okay? But then I have only shown you part of the picture. I've shown you a close-up of this particular picture. Let us look at the complete picture. Now, what do we see here? Something funny? Okay.
Yes, sir.
Is the dog really sad? You
No,
would say,
sir.
no way. The dog is not sad at all. So with a few props here and there, the whole mood of the students, of the participants has changed. Yes or no? Right or wrong? Correct? we
Yes,
have
sir.
made a complete change in the atmosphere of this particular talk by just adding a few objects here and there. And the previous one, which was a cutout of it, a small part of it, did look like a sad dog. Okay. So what is the learning from here? You need to analyze the complete picture. You cannot take a part of the picture and then come to a decision. Okay. So it's a very funny kind of an example I have sort of put together, telling that it's a sad dog or not a sad dog. So when you take up a robot trying to examine a scene, which will have obstacles, which will have rewards, which will have work to do, how to possibly handle them, how to possibly go about it. So you need to analyze every object in proper detail and then put together in context what is the work to be done, or where am I, what am I going to do next, what will be my next move in that case. So the solution here, of course, what we get to see from this particular example is that a lot depends on the context. Okay, so get to see the complete layout, see the objects that are, it's a hard work. It's not easy. For you, it's a quick analysis as a human being, but for a robot, for a machine, understanding of that scene, a lot more has to be done. Okay, so do not at all, the solution here is that do not at all train one image as one consolidated image and try to get a decision. Try to find out the possible objects that are there, use them, connect them, train all of them, and find out what that possible image can be. Is it clear to all of you now? Okay, it's a difficult one. It's not the easiest thing to do, but that is what, as a human being, you do it with a lot of success. Things work out very well for you. Okay, right. So let us move ahead. Now let us look at computer vision. What is computer vision? For us as human beings, we see a beautiful picture with a clean water. You would like to really go underneath it in a summer situation. Okay, and some people would like to do a lot of fishing in this particular water. Some of you would like to have a one-day picnic close to the shores of this water. But for a poor computer, it gets to see only the intensity values of colors and brightness. That's it. That is all the computer gets to see. So here, making sense out of these numbers is a huge challenge. Okay, this is what we will be doing it for maybe many years to go. Okay, it's not going to be a closed loop solution which we will get very soon. But how do you attack, how do you handle such a problem? So we would like to look at that. Okay, so what goes, or what a computer sees, is this particular image which I have put. I guess some of you can correlate this image with something they have seen before. Can you make a guess? Anybody in the audience? Can you make a guess if you have seen this before, the right image before? Anybody? Yes or no? Anybody seen it before? Think about it. I'll give you a clue. It came in a movie, a science fiction movie, English movie.
Matrix, sir. Matrix.
The Matrix. Yes, you got it right.
Yes.
So this particular picture, I've clipped it from the movie Matrix, where a series of codes, okay, codes, tokens, as we call it in computer science, are being flashed on the screen with no knowledge of the meaning of these codes. The day we figure out what these codes mean, you have understood the scene. The same thing is happening to you here, to the computer, where a series of numbers are there for each of the pixels that are there, which constitute this particular image. So how to handle them forms the most part of computer vision. Okay. Now let us look at something more interesting. We look at computer vision as a definition which says that it deals with the development of theoretical and algorithmic basis by which useful information about the 3D world can be automatically extracted and analyzed from a single or multiple 2D images of the world. So we possibly can try to look at the 3D image and then get out from it one or more 2D images and analyze the world. Is it clear? We are already losing information because the 3D world is mapped to a 2D world. Of course, we have stereoscopic vision, but not very accurate, approximately. Okay, but that has to help us to analyze a particular scene. So whenever you look at a CCTV camera or a certain kind of SLR camera or your mobile phone camera, that poor fellow has got only one eye. Okay, that poor fellow can see with only one eye, so no depth is properly visible. And with that, you want to expect all the objects to be identified. It's only a flat plane that the fellow can see. The camera is not really giving you a lot of information, but your job would be to extract most of the information from the given image. Okay, so the picture at the bottom, which I've put together, is actually a spiral. But if you move the spiral around, this is because of the persistence of vision that you tend to feel that this particular spiral is dynamic, it's moving, it's actually in motion, which is not true. But that again happens because of an apparent illusion that the black circles are embedded in the back of your brain and the white circles are taking that place, and hence it appears that the spiral is in motion, okay, as if the disk is turning, moving around or so. This is just a quick trick which happens to your mind. Okay, so what are the components now of a computer vision system? It's important to understand that whenever you look at a domain, many of you would be taking up, rather quite a few of you would be taking up computer vision, something similar to computer vision, analyze data, and then get some answers. The first and foremost thing to look at here is to understand, very clearly understand what you are dealing with. You're going to deal with images, and images are subject to many qualities. The first quality is the camera. How do you capture that image? What equipment is used to capture that image? Is it your good old trusted mobile phone camera? Is it a digital camera, which is approximately 10,000-12,000 rupees, which is a much better camera than your mobile camera, possibly much more reliable? Low lighting is handled quite well. Is it a state-of-the-art digital SLR, which has got a huge resolution? It will capture everything very minutely, very accurately. Is it a working kind of a CCTV camera with just you can make out, the motion movement are properly done? Is it a black and white camera? What is it? So the camera is a major criteria which will tell you, which will allow you to control or your solutions, which will have a major bearing in your solutions. The second one is the analysis device, the computer. This is where most of you will work. You will try to develop algorithms to crunch the data which comes from the camera to get something useful out of it. So what kind of algorithms go in? Are you going to have very dedicated kind of feature extraction methods? Are you going to have several types of feature extraction methods taken up, or a single one? Are you going to do some very fancy kind of modeling techniques and then go about finding out decisions? Or are you going to use very simple run-of-the-mill kind of thing to get quick decisions? I want to make this work on a very small cell phone. I can't afford to use very heavy algorithms there. So how will you make it work? So what kind of hardware you're going to use, the computer, to actually solve the problem? Is it a simple cell phone or something much more than that? So the scene interpretation or the hardware which you will use along with the algorithms that go in. The third one is the object itself, the scene. What are you going to click? What is the interest? Is it a vehicle which is coming towards you? Is it an insect which is going to move at a pretty high speed? Or is it night photography where a tiger would come in and eat something which you have put and you want to examine and find out the behavior of that nocturnal animal or something like that? What is the scene? What is the layout? So that is something that will have again a major bearing in the analysis. So this you should try to have some control over the scene. And the last one, but not the least, is the lighting. An image is as good as the quality of lighting that you can put on the scene. Now, this I cannot overemphasize, in a virtual meet. But then I hope I will be able to put this as a quick example with a quick experiment, which all of you should do. Now, what I want from you is to take your mobile phone, switch on the camera, and point it towards the tube light which you switch on right now, and examine this tube light in your camera view, the display. Do this right away. I'm repeating once again. Switch on the tube light, switch on your mobile phone camera, don't use the flash, and point it towards the tube light, okay, or a CFL bulb or an LED bulb or whatever it is in your room, and watch what you see in your display. Can you get to see the bright tube light or the CFL bulb? Try it out. It's an experiment. Try it out. Yes.
Yes, sir.
Now,
Apart from this,
can you possibly see the flickering of the tube light? A bit of flickering from the tube light. On the display, is the tube light stable? Most likely it is not. Most likely. If you see carefully, the lighting source has got oscillations. And the oscillation will have a frequency of 50 hertz, which is the line frequency of India. So 220 volts and 50 hertz or 50 cycles per second is the AC power supply. So that, though stabilized in your LED lighting or your CFL, or most unlikely rather, your the normal filament lamp, but the cycling will be there. So remember, your camera is picking up all those cycles of light. So sometimes the image is bright and sometimes the image is not so bright. So you are already having an unstable kind of data into your system. It's not good news at all. It's bad news. So your computer has to handle that unstable data to start with. You don't even think about it with your eyes, do you? When you look at a tube light, are you really worried that it is flickering at 50 hertz? No, you don't. You are already comfortable. Your eyes can absorb all that, or your eyes are incapable of figuring that out. If it is less than, say, 14 cycles or something, then it might flicker, or 22 cycles or something. Then only it would flicker to you. Otherwise, it doesn't. But a camera will always take it up because the camera frequency scan is far more. It's 60 or 100 or 120. The line scan is much more. And hence, it will pick up that flicker. So most of the modern cameras that you get has a parameter which allows you to input the line frequency, line power frequency, the power line frequency, so that there is an algorithm to minimize such flicker. You check it out in your mobile phone, it most likely has a anti-flicker option, which tells you what kind of light and what is the power supply line frequency. So that will control the amount of flicker to some extent, not to a great extent, but your algorithm has to take into account these issues. So remember, the lighting has got a major say. Lots of problems happen with lighting. So I'll give you an example. If you possibly walk down to a recording studio, to a audio-visual studio, you might be surprised to find light boxes or lighting sources where there are screw mount bulbs that are there, and those are the old filament lamps. where there are filament, it will become quite hot if you switch it on for 10-15 minutes. You can't touch it, you will burn your hands. So it actually minimizes these kind of flickers, and those bulbs are coated with sort of chemicals and things like that, which actually put up a proper, what we call it as a color temperature. Okay, so that is 6500 Kelvin or 2700 warm light, warm white color, this thing, or maybe below that, which is orange or glow kind of light, orange kind of light, warm light, or even cold light, sometimes bluish kind of light. So these bulbs actually put out lights, I mean the light of a particular kind of close by particular dominant kind of frequency light. So this again, lights up the scene, and your analysis becomes a much more easier proposition. So flicker and the quality of light. You must control this carefully, otherwise you will find that whatever experiment you do in your lab, you take it to another lab, it just fails miserably. It doesn't work at all. You take it out in direct sunlight, all haywire will happen. Things will all go bad actually. It won't work at all. Okay, things will be in a very bad shape. So you have to make sure the lighting is under control. Okay. So these are the major components of a computer system. I really wanted you to just, know about it. You look into every aspect of this, do some detailing of this, and then go about ensuring that a human being can handle it nice and properly. A computer or a computer system will also be able to handle it with some reservations, with some preconditions or constraints in a proper way. Okay, in a comfortable way. Okay, all right. So let us move ahead. So we look at a few, related disciplines like image processing or computer graphics, trying to represent a particular object in a mathematical form, or doing some pattern match or pattern recognition based on looking at an image and looking at another image, trying to find out what is common in it. Okay, what are the commonalities of two different, images which may have similar patterns inside, or robotics, which is a very very popular area where you try to mount things, mount sensors on devices or vehicles, and ask the machine to take decisions so that it does a predefined, task, like bring me this, go and do this part and come back, do some recharging, or fetch me some, stuff from a particular place, or some AI algorithms where you try to make things learn, make an algorithm learn for an unknown or an unseen kind of a scenario, and many more, such areas are there. Okay, so these are areas where you can sort of start, looking at. Okay, right. So I'll sort of get into some applications to get you a feel. I'm not going into any mathematics. There is enough mathematics, which is there. So it's best if you take them up in a bottom-up fashion rather than from a top-down fashion. So first, identify the application. Find out as a human being how possibly you will solve it. If you are able to solve it as a human being, there is a good candidate algorithm which you can find out from the literature, tweak it to that particular application, and then solve the problem. This is one way of solving a problem. There is another way of solving a problem. First, you learn about the background theory of all possible kinds of algorithms that are there, become wiser, and then after that, take an example and start putting all those algorithms there on that data, and then scratch your head and say that this algorithm works best for this application. And then you go to the bottom and say why it possibly worked better. This also is another kind of a top-down kind of an approach. Okay, so I will take one application quickly and show you how this looks like. Okay, so can you see an image where there are four, rockets or some missiles sort of that are fired into the sky? Four rockets that have gone through. So this is actually a news item which came up in July 2008 in press, and there was a lot of crisis going on over Iran, and somebody was trying to fire missiles, and they put images in the internet saying that we are missile ready, and anybody tries to do something, we will do a lot of trouble and things like that. And then later on, with some image processing techniques, it was found that this image was not entirely true. The true image was this. So one of the missiles failed to fire. This is what actually had happened. So this was not a complete, success story for the people who claimed that it is a success story. So that was a false story, a pseudo-false kind of a story, which was put up in the internet. Now, from here to here, can you possibly make algorithms to find out how this happened? So there is a lot of cut paste which was done, manipulation which was done to this image to come up to this image, and it was found that some portions of the original image, which was this, was cut paste and put on the bad image here, and then finally they got this particular image. So this kind of forgery, so to say, doing not so good things about generating images by taking the original image, cut pasting it with parts of the same image, is called image copy move forgery. So you have a lot of information, in the internet. It's a major research area where, given an image, can you find out possibly if it has been faked, if there are parts of the image which has been copy pasted, and this image is not entirely true. It's partially true. I'm not saying it's false. It's partially true, but not entirely true. So this area is called copy move forgery, a very significant part of image processing these days. And I guess all of you must be getting a lot of information through your WhatsApp and Facebook, where you don't know whether to believe what you get to see, though it looks believable. The first few seconds you appreciate, or you tend to believe that this is true, then you might start thinking it's too dramatic to be true, or it's too heroic to be true. And then over a period of time, you find that it's a fake thing. So can you make algorithms which can actually do that, which can figure out that use the internet, whatever resources are there, and then figure out all the images in the world that are there, that's at your disposal, figure out that this is a fake image which is there. Okay, so this is a major part where forensic sciences and lots of places, you try to find out if forgery is done to a particular image. Okay, so this is the image copy move forgery. I'll show you one more example. Now you can see this particular example where our prime minister is peering through a particular place here, a port kind of thing, where a lot of floods have happened, and trying to see if what to do about it, and he's sort of going on a tour. But then it was later on found that this particular image is doctored, or it's a forgery based image, and the original image was this was taken up somewhere else, and somebody cooked it up and made this out of it. So can you have an algorithm which can find out that this is the original image, given all the images of the world at your disposal? What algorithm would you use? So this is the copy move forgery domain for you. Okay, so like this, there are rather several images. Like this is a complete domain in itself. You can try to figure out techniques that are there, and then try to improve on them, and then find out whether your method is much more superior in a particular context to find out forgery. Okay, copy move kind of forgery. Okay, so again, there is another one which I'm going to show at the last one. So this is again a manifesto, the manifesto of a particular political group in India, where we find that these two portions have been copy move forged. Okay, so there is forgery out here as well, where a part of the image has been copy moved and put out here, giving it a look that the whole place is full of people. So this is probably way back in 2014 or so. You can look up at the internet and you will get all these images available. Okay, so this is another, this is a pretty popular, and it's a very popular domain to work on. Okay, right. So I'll quickly, talk about the research scholars who are working with me right now. P. Bhagat is my sort of senior most researcher. His main area his speech understanding, and his specific area which he is handling. He has just recently submitted his thesis, so you can get to him through my website and talk to him. He's looking at speech processing, where his area is trying to find out how to characterize speech events using graphical processing techniques. So there are many traditional techniques like hidden Markov models, analysis based on features like Mel frequency capsule coefficients, and many other, temporal or spectral features. So he is trying to look at how to characterize speech using graphical methods. Okay, so this is what Bhagat is looking at, and Sadhu is looking at image processing, and his main area is to find out image characterization. How would you characterization image and particular image with applications to matching problems? Again, it's closer to your copy move forgery kind of thing, but not really. He's trying to look at how human faces can be morphed, and you can have fake images of people which can be automatically detected. So those algorithms are what he is looking at. Vanshali is looking at the medical image processing side, where she is looking at anomaly detection of endoscopic images, where you have images of various canals inside the human body, where possibly anomalies or diseases may be there, and can we have a first look at possible starting part of some warning signs of some major diseases which can be there in a in a particular anal canal or a particular canal. Okay, so this is the endoscopic data which she is looking at. This is a very difficult and an interesting problem, where it can help doctors to actually focus on certain parts of the videos to find out if any disease is progressing which may be missed by humans. Okay, so during the endoscopic procedure. All right. So Shushma is looking at language learning, which is a pretty fascinating area, where she is looking at the language Manipuri, which is a tonal language. There are very few tonal languages in India, and Manipuri is one such language where the tones give different meanings to the same word. So the same word spoken in different tones have totally different meanings. So she's trying to find out how a human being learns the Manipuri language, and then we try to mimicry an automata based on that. So she's looking at this particular aspect. Meenakshi is, of course, she started her research, and she is looking at robotics and IoT and trying to develop algorithms of how to spawn or how to make algorithms which would efficiently use the minimal of robots and get some work done, okay, in a distributed form. So she is being jointly guided by me and Professor S.V. Nair of our department. And Komal Bharti, she is just started off with her PhD, and she will be looking at speech modeling techniques. And Sanjay also, Sanjay Das, he's a part-time student, and he is going to look at regional speech characterization, and he'll be taking up ground, applications like Assamese speakers, and what kind of applications specific kind of speakers require to solve their own problems. So he'll be looking at a more ground up kind of solutions, where the results and the, so to say, the quality of work will be judged by the people who will lend their voices to him for analysis. So these are scholars who are working with me, and one more scholar will be joining me soon, maybe today actually. Okay, so she will be joining us with this particular group, soon. Okay, so these are the things which I wanted to talk about, and let me quickly wind up. And thank you for listening to me. I hope it has not been a very boring lecture for you. I have just started to I've given you a touch or a feel of how a human being looks at speech, and what aspects should we keep at the back of our mind to ensure that we make a successful image processing system. Okay, thank you so much, and I am open to questions. You can pose the questions to me. Okay, thank you so much.
Thank you, sir. Sir, it was really an amazing session, sir. So thank you once again, sir, for sharing your profound knowledge with us, sir. So, Sir, we have a few questions today, right now present, sir. I want to present this. Okay. Sir, may I request to kindly stop sharing your presentation, sir?
Yes. Done.
Sir, is it visible, sir?
It's coming up.
Yes, sir.
Yeah, it's coming up. Please wait. Yes. So we have the first question, which is from Aditya Kumar.
Yes.
There is some formula or something different which are capable to change that image by our imagination. How? This is a very fascinating question. This is the crux of image processing. You have actually put it in your own words. How do we possibly converge to a solution to something which we see? See, this answer, if we can get a closed loop proper solution to this answer, the problem of speech processing would be over by a great extent. Maybe 80% of speech processing would be over already. So what you are asking here is that from a scene, from an image which we get, to what we put at the back of your mind, back of our mind, we put that something at the back of your mind. I might ask you, close your eyes and think about that dog which is sort of sleeping there blissfully. So you have kept some part of that image. It's not one-to-one anymore. It's a very rough, coarse image of that particular dog that you can see with one or two props which are there here and there that makes you smile. And that allows you to form a decision. So the idea here is, if you can make a system which is capable of taking the smaller, important, significant pieces which is there in the image, you are possibly on your way to recognizing the main object. This is what my take is. This is open thinking. This is you can say common sense, that if I know there is a lot of water and a few palm trees, I would be tempted to say that I'm close to a beach where there is some sand. This is what I'm trying to say. So from our imagination of what we already know, we can possibly converge to a solution. So I hope this is a plausible answer to your question. Okay, is it all right?
Yes, sir.
Right. I'll go to the next question. M. Thakur. Sir, what if all other creatures' vision can be merged in a device so humans can able to see in the night and other conditions? Please provide your views and oblige. This is a very fascinating question once again. I'll give you an example and you will be surprised what little we know about vision. Now I'll tell you something, please listen carefully. It's interesting. You must have looked at bats, okay? Chuchandar as we call it in Hindi, bats, and they don't get to see too well. Their eyes are good, but their eyes are not so good. So what do? They use their voices, they use speech. So they use sounds, high frequency sounds, and they sort of focus it and put it to the environment, and the reflections which come back, they get to know the location, the distance, if they will crash. And they do this in real time when they are stationary and when they are flying. Now this is something we have heard, we have been told since our childhood, or in our schools also we have been told that bats listen through their ears. Even a dog listens pretty well through their ears. I mean, their ears are pretty. You try play some prank to a dog by saying something, the fellow will wag its tail. It knows, it figures out, it will read out, it figures out if you are joking or you are sad or happy without even using the eyes. Similarly, a bat is able to figure this out. Now the question is, it is much beyond this. A bat can actually figure out the reflections from the environment, and if the reflection is coming out from an object, if it is edible, if you can eat it, and what kind of taste it will have. So if there is a mouse which it has, which gets the reflection back into the bat actually knows what will be the taste of that mouse. This is the kind of clarity a bat has, and hence it survives in pitch darkness. It doesn't use the eyes at all. It doesn't hit anything. Even if you put a small wire, it will evade that wire at the last moment. It won't get entangled and die. It'll be able to, so that kind of a resolution quality is there. So the question which you have put up is pretty good. If we can borrow some of these ideas from the bat, from the dog, from the seal underwater, and try to take a subset of it and put it on a robot, you can have amazing results rather than just putting a visual camera and hope to God that it works for you. It will work all right only within the arena which you make inside a lab. It might utterly fail when you take it outside the lab. In a real life situation, life will be extremely difficult. The kind of obstacles that are there are unbelievable. If there is a glass piece that is there, you can't get to see, you will walk right through it. You'll break the glass, you will get hurt. But if you use your other senses, like reflection, you might save yourself. So you need a multi-modal approach to actually solving this problem. Okay, I hope I am able to answer this question. Okay,
Yes.
all right. I'll take up the next question from Usha Mary Sharma. Sir, how do we solve these issues that machines facing to identify or visualize image and predict them? So this is what is proposed to us, that I am giving you a scenario, you analyze and take a decision on it. So again, let us quickly, I do have some time. I have about 5 minutes, right? Okay.
Yes.
So I will ask you to do this experiment, all of you. It's interesting. Try this out. Look at what is behind you, behind the screen that is there. If you are sitting next to your laptop, in front of your laptop, look at what is beyond your laptop screen. So it's either a room with some stuff there. If you are in an office, there will be bookshelves there. If you are in your house, you're holding up a mobile somewhere in your room, there will be a window out there. Look at the background for about 10 seconds very carefully, and then close your eyes and don't open it at all until I say so. Look at the scenario, the scene in front of you. It's a camera right now. Absorb what you can in 10 seconds and close your eyes. You're going to open your eyes when I say so. This is the experiment. You have looked at your background. Close your eyes. Can you now visualize and annotate the background? Can you write or say a few sentences of what is there in your background? You have to scratch your head to do this. It's not easy. You would say, I can see a curtain when I close my eyes, the curtain color is this, there is light coming through, or there are 4 or 5 books which I looked at yesterday, but I have not looked at it right now, but I know it is there. Okay, that's what you have retained. Then you can talk about few more things, that there is a talk going on, there's a monitor in front of me, or a mobile phone with this thing written, a scratch on it, which is in front of me. You can start annotating your scene. Once you start doing this, you will have several, you can open your eyes and validate your claim that this is what I thought I saw and this is what is already there. So once you have validated these points, you have to prioritize it, meaning which are the more important ones which are needed for processing and which are the ones which are just to be ignored in the processing. So do this first, and then after that, with those objects, you do a detailed mathematical treatment of them to find out what objects they are in absolute clarity, and then take a decision. I guess that will be a far superior solution to the given problem. But it is, of course, it will have a multimodal approach. You have to train many other than the object which you want to. If it is a cone which you want to recognize, you have to know all about the other objects which can be there in the image. That learning is needed. So all types of cones it will try to grab if it knows that it is not a other object, it is a cone. So you have to do that kind of elimination method also in the system. Okay, so I hope I have answered this particular question. Okay, so let me go to the next question. Dr. B. Srinivas Raja, how to estimate the noise content in images? This is a real difficult problem. For our eyes, we safely, I just showed you with an experiment that you have all kinds of flicker going through. My God, what will happen if inverter is working and your tube light is running? You cannot believe the kind of cycling that will happen if the battery is not in good condition and you are supposed to make it work. If the genset is working, the genset will have cycles, this kind of cycles in the power supply. The 50 hertz cycles is already there, but the genset, the cycle that is there, the big flywheel that is there, will have cycles. Those are mechanical problems. So that will influence your power supply, and that will again influence your algorithm. That will influence the lighting that will come. The oldness of your light source will also have a say in the kind of lighting that you will have. It's very difficult. They will all introduce noise in the system. It's very difficult problem. You just put a new tube light in a lab and work, you'll have different results. And you work over a period of time, after 2 years, that light will be very different than the ones which you put on the first day. So you have to work accordingly. It's very, very tricky business. But then we expect every time that it has to work. So what can be done here is to have a pre-processing module which will involve finding out the quality of light by pointing the camera to the light. You look at the light source and decide what kind of lighting it is. Then you point the camera to another place and then you substantiate your claim that the lighting source is like this. Then you find out the quality of the camera that is there. Okay, because that a good quality camera will possibly reduce some amount of noise. I'll give you an example. These are difficult problems. If you use a very high resolution camera, that also is not good for health, because the algorithm will be not real time, because you will have a lot of pixels to handle. So that is also another problem. So these are issues that have to be looked at and then come to a middle line where it gives you some reasonable results. Okay, so let me quickly take the next two questions. It's going to be 1 o'clock. Okay, so Anuruddha Reddy has pointed out, how can we differentiate particular image with various mirror images? So this is where, of course, copy move forgery kind of thing might help. And there are, of course, targeted algorithms where human faces are, handled. So if you are going to deal with mirroring, there are algorithms in Python libraries and things like that. So you can go deep into those libraries and find out what kind of, what algorithms are useful for you. And those are basic, image processing algorithms. Okay. And Gopal Krishna has pointed out, how can we use computer vision to cope with COVID-19? Now, this is a major problem which we all have to go through. And if you can even make a small dent in finding out characteristics of COVID-19 in terms of either security in a particular place, in terms of behavior of symptomatic patients who are moving around in a particular place, that itself will be a great, benefit in filtering out and doing a secondary level analysis for those people. So speech can be used where coughing is to be detected. Images can be used where particular movement of touching the nose or touching the mouth, or people who are not wearing masks, they have to be detected and they have to be told that, they have to be instructed that you have to wear the mask in this particular area, you are not wearing your mask, or things like that. So these small things in a particular place will make a big difference over a period of time. I don't think this thing is going to go away soon. So we should have CCTV cameras where the inputs go directly into a real-time system which warns the security to tell that these guys are going to get into trouble or put all of us in risk. They have to be controlled. Or these people are coming in, they need to be taken to a particular place where they can do their work properly. They can be color coded. Okay, the mask can be color coded. So these kind of applications are very much needed. So you have to find out use cases for them, and then try image processing algorithms. And in the medical side, where microscopic data is concerned, there is a lot of work which can be done. Okay, okay. Thank you so much. Okay.
Thank you, sir. Thank you
Over to
for your
Malaya.
explanation, sir.
Productive workshop, and do take feedback from all students, from all the participants, and also try to see the requirements from the participants. Do they really want the mathematical formulation, or do they want only the resources part of it, or do they want use cases part of it? So we can possibly have a repository in you can put it in NIT Silchar in the website, where useful information can be there, where either you want data sets which can be mirrored there or kept there as links, or or necessary lecture notes which can be there, or use cases where challenges can be put up, where people can try their own algorithms and project their ideas there. So that can be a platform. Okay,
Yes, sir.
so with these suggestions, let me close for today. So do have a nice time, and wish you all the best for the remaining part of the workshop. Thank you so much. Thank you.
Thank you, sir. Thank you so much, sir.
Okay, okay. Bye. Huh? Bye.
Thank you, sir. Participants, now we can have a break for 2 minutes. After 2 minutes, we'll be entering to the last session of this day 3 of MLCV 2020. Yes, sir. Welcome back to the last session of day 3 MLCV 2020. Our speaker for this presentation is Sri Jyoti Prakash Medhi. Let me introduce Sri Jyoti Prakash Medhi. Jyoti Prakash Medhi is an assistant professor in the Department of Electronics and Communication Engineering, Guwahati University. Currently, he is pursuing PhD in the Department of Electronics and Electrical Engineering from Indian Institute of Technology, Guwahati. He has completed MTech in Bioelectronics from Tezpur University. He also served as head insert in the Department of ECE, Guwahati University since 2014 till September 2017. His research areas are biomedical signal and image processing, instrumentation, and robotics. He has published many research findings in different international journals and conferences and has contributions to book chapters. Now, may I request you, sir, to kindly start your presentation? Sir, kindly. Sir, kindly on your microphone, sir. Kindly unmute, sir.
Okay.
Kindly share the
Okay.
PPT.
Okay. So am I audible now? Okay. So okay, is it presenting?
Yes, sir, it is visible.
Okay. Thank you. So today I, Jyoti Prakash Medhi, welcome you to the today's session on FTP on machine learning and computer vision. So today I'll be discussing on various research probabilities in biomedical image processing in the area of diabetic retinopathy using fundus and OCT images. So our topic of discussion will be automatic diagnosis of diabetic retinopathy. So in retinal images, we'll be discussing on fundus and OCT images. So our discussion will be mainly when in this format that we'll be discussing on diabetes and various eye physiologies and how diabetic retinopathy affects our eye or retina during the process. Then we'll go through the research challenges that are required for identifying these abnormalities in our retina. Then finally, we'll be going through the automatic diagnosis process of diabetic retinopathy. So this will be an overview of how we identify diabetic retinopathy or other symptoms using various image processing tools. So to start with, first of all, diabetes. So diabetes mellitus, as we commonly know, known as diabetes, is a metabolic disease that is caused by high blood sugar. And the hormone insulin moves sugar from our blood into our cells and to be stored or to be used for energy. Now, with diabetes, our body either doesn't make enough insulin or cannot effectively use the insulin form. So, diabetes is very much familiar to all the individuals, and it has created place in almost in every home of around the world. So it is mainly caused due to the present lifestyle of ours, starting from developing countries first, and now it is peaking at the underdeveloped ones. So as per the statistics, we can see from 2019, 460 million people worldwide are affected by diabetes. And these are only reported cases. But there are many more unreported cases which will also increase the number to a larger extent. And if we see the ratio with respect to gender, then it is almost 50-50 percentage. Now, this diabetes not only affects the blood sugar level, but also affects other organs, such as if it affects our kidney system, then it is called as nephropathy. If it affects our neural system, then it is neuropathy, and it also affects our retinal system or our eye, which is called as retinopathy. So today we'll be discussing on how this diabetes affect our retina, and then what are the signs that are visible over our retinal images. So to start with, we must see some preliminaries of retina. So retina is a layer lying at the back of the eye, as you can see here, and a cross section of retina has been shown. So the light falling from the cornea through pupil, it enters the eye, and passing through the lens, it finally reaches the retina. So from retina, which consists of numerous number of rods and cone cells, they convert this light energy into electrical energy, and this electrical energy is sent to the brain for formation of the image. So now, if any abnormality that may come in this direction of light, or while the light is passing through towards the retina, if there are any obstacle present in our eye or it present over the retina, then the vision gets blocked. So due to various cases, like due to our aging of a person, or diabetes, or due to high blood sugar level, and due to hypertensions, what happens is there are various changes that occurs across the retina. These changes starts blocking the vision if they form over the region where the light is falling over the retina. So today we'll be looking at those symptoms with respect to the diabetic retinopathy. So now, in order to see the effects of retina, we go for mainly two type of imaging. So these imaging are fundus imaging systems and optical coherence tomography images. In fundus images, what we can see is it is a two-dimensional top view of the eye, or we can see the directly front facing area of the eye, where we can see the overall retina, and we can adjust the camera in such a way that as per our requirement we can get the images. So in a fundus image, as we can see on the right hand side, so uh, the fundus image consists of various regions, like the optic nerve head is called as optic disc. Then the in middle portion of the fundus image is called as macula, and the light that is falling over the eye directly comes and falls in this region of macula, which is called as fovea. So if any abnormality comes over this region, then the light gets distracted and it cannot reach the retina. So uh, these are the various regions. Then blood vessels are there, which nourishes the retina. Now, this is the top view, or this is the front view of our retina. But in order to know what is lying beneath the retina, or the layers of retina, we have to go for OCT images. So in OCT images, as you can see here in the left-hand side image, these are various layers of retina, starting from ILM layer to the RPE layer. So in order to study what are the changes occurring over the retina, then we have to study definitely for the overview of the retina through fundus images. Then to understand what is lying beneath the retina, that means in the layer regions, that we have to identify it by OCT images. So for the analysis of diabetic retinopathy, we have to go for analysis of these two images. There are various other imaging are also available, but presently the doctors mostly go for these two images. So to move on, the visual changes that occurs during retinopathy. As you can see here, the first image is a normal vision of a person. The second image, as you can see, there are some blurring effects start occurring. So this blurring effect starts occurring due to the presence of retinopathy. Now, the third image shows the severe case of retinopathy, and this stage is called as maculopathy, where the abnormalities involve the macula. As you can see here, in this case, what happens is the person can see the clock, but he cannot identify the time. So these abnormalities, when a person can observe within himself, by that time it is very much late. So, in order to cure a person from retinopathy, then what we have to do is we have to go for earlier detection of the disease. Otherwise, if we go at a higher stage of the disease, then it can be decreased, the effect can be decreased, but it cannot be reversed. So that is why we have to go for earlier detection. That is why nowadays, whenever a person is having diabetes, he is suggested for going into annual eye examination. So this annual eye examination, what I may also suggest that we must go, everyone, whoever is either having or not diabetes, but they must go for an annual eye examination to understand whether your retina is perfect or not. Because if you start observing the differences, till that time it is very late. So to move on to the changes. So as we can see here in this slide, the left side image is a normal retinal image and the right side image is a diabetic retinal image. Here, the various abnormalities, as we can see here, these uh, small dots, red colored dots, these are abnormalities, these are bloods, and these yellowish structure, these are also abnormalities. So I will tell in the next slide what are these abnormalities. So to move into various abnormalities formed, so the physiological changes that occurs in our retina due to diabetes. So now, as we have already discussed that due to diabetes, various changes occurs. Now, these changes will affect the retina due to the non-availability of oxygen for our tissues. So, as we know, all the oxygen that is present inside the blood vessel, they remain inside the blood vessel only. They cannot move out due to the insufficient amount of insulin. So, due to this case, there is a higher amount of oxygen demand from the tissues that are present in our retina. So to nourish that retina, what is being done here is the blood vessels starts developing few abnormal structures. So these abnormal structures start with formation of small bead-like structure across the blood vessels. These bead-like structures are called microaneurysms. So the microaneurysms that are formed in this blood vessel region, sometime at a later stage, what happens is this microaneurysm burst in order to supply the oxygen. So for when they burst, the blood leak out from the blood vessels and they fall over the retina, and they form uh, dead blood tissue, dead blood cells over the retina, which are called as hemorrhages. So depending on the shape and size of these blood clots or blood dead cells, these hemorrhages are of various types. Now, along with this blood, the blood vessels also have various protein and lipid structures present inside the blood vessel. So when this protein and lipid extracts fall over the retina, they give rise to exudates, which are earlier which are divided into two types: soft exudates and hard exudates. Then soft exudates are nothing but they are formation of or deposition of the earlier stage exudate regions, and hard exudates are more amount of deposition of these exudates. Now, the people also call the few type of soft exudates as coronal spots. So these are the abnormalities which we can see over the retina in bright regions. So as we can see in the right hand side, these dark spots are nothing but these are the hemorrhages, and smaller dots which are hardly can be visible, those are microaneurysms. And these bright regions represent the exudates. Now, as the disease progresses towards the final stage of the diabetic retinopathy, what happens is when the blood vessels are not sufficient enough to produce or to provide the oxygen demand, what they does is they starts growing newer blood vessels, which are very much tiny and thin in structure, as we can see here. So these blood vessels, after they are developed, they also face the same condition of this oxygen demand, and being fragile, they leak at a higher rate than the actual blood vessels. So these blood vessels, when they leak, they produce higher amount of hemorrhages, which finally blocks the vision, and the light cannot enter through the retina. So the person gradually becomes blind. So these are the changes that we observe over the fundus image. And for automated analysis, we have to go for analyzing these differences from the normal images. So to move on to OCT images, so in fundus image analysis, we can understand only whatever we can see from the upper layer of the retina. But if we go for the higher analysis of the retina, if you go for checking the retinal layers, then as we can see here in this image, left-hand side fundus image, we can see there is a symptom of diabetic retinopathy. As we can see, these are few blood clots or blood leakage. But when we go into the OCT image of the same person, then we can see there are huge amount of changes occurring in the OCT layer. As you can see, this lower region image is a normal OCT, and this is a diseased OCT. So the change, as we can observe here, this region is totally swelled up like this due to the deposition of these abnormalities. These are nothing but deposition of bloods and exudates, so which are called as cyst. Now, in order to identify the severity of the person, we definitely have to go for the analysis of OCT. So next is type of the diabetic retinopathy, that means the stages of retinopathy. As you can see here in the left-hand side image, the first image is normal fundus image. Now, with the progression of diabetic retinopathy, first stage is called as background diabetic retinopathy, where we see the presence of microaneurysms. So, this presence of microaneurysms are earlier people used to check this microaneurysm using fluorescent angiographic images, but nowadays the higher resolution fundus cameras also detect these microaneurysms. Now, with progression of the disease, the next stage is called as pre-proliferative diabetic retinopathy, which is given in the third image, in image C, where we observe various venous bleeding, then intraretinal microvascular abnormalities, which are called as IRMS, then multiple blood hemorrhages, then cotton wool spot, and finally hard exudates. So when you observe these changes, then the stage is called as pre-proliferative diabetic retinopathy. Now the next stage is diabetic maculopathy. So the diabetic maculopathy is occurred when these abnormalities are present at a 2 disc diameter range from fovea. That means if this is our optic disc, and the optic disc diameter, if we calculate and measure from the fovea, then at a region of 2 optic disc diameter, if there are any abnormalities, then it is called as diabetic maculopathy. That means if I draw a circle here, that circle, if it contains any abnormality, then that is called as diabetic maculopathy. As we can see here, there are various abnormalities present within that region. Next, the higher stage is called as proliferative diabetic retinopathy, where we observe neovascularization, as we have discussed earlier, the formation of new blood vessels, and finally we observe vitreous hemorrhage. Now, during neovascularization, the blood vessels that are being formed, they may enter into the vitreous of our eye. Now, if those blood vessels leak inside the vitreous, then they cause massive amount of deposition of blood, and those blood block the light coming into the eye in the vitreous itself. So that light doesn't even move inside the move through the vitreous of our eye and never reach the retina. So ultimately, the person becomes blind. So proliferative stage is the last stage of diabetic retinopathy. So these are various stages of diabetic retinopathy. Now, in order to understand diabetic maculopathy is also further classified into 3 stages, as we can see here, considering fovea at the center, and the outer circle is at a distance of 2 optic disc diameter. These are 3 circles being drawn. Now, these 3 concentric circles, I will discuss in the consecutive slides what are their distances. Now, these 3 circles give us the stages of diabetic maculopathy. Now, in this circle, if anything lies in the outer circle only, then the stage of the diabetic retinopathy is called as mild. If it is present in the second circle, then the stage is called as moderate. And if it is lying over the third circle, that is the innermost circle, then the case is called as severe. That means the severity increases more when the abnormalities move towards the fovea. So if those abnormalities form over the fovea, the person automatically becomes blind. Now, these are the stages of diabetic maculopathy. So in this first section, we have already discussed what is our eye, what is our retina, then how diabetes affect our retina, and these effects, how we look them or how we observe them in various imaging conditions like fundus images and then OCT images, and how these abnormalities are being formed. Now, next requirement of our discussion of or the as we can say the requirement of our research will be to find various challenges that we possess or that we come across during analysis of these images. So, go into the various research challenges. So, we start with first. Let us discuss how we identify diabetic retinopathy. Then we'll go into the challenges one by one. So, in order to identify diabetic retinopathy, our primary requirement is to detect the optic disc region, or the optic disc detection is the primary requirement. Then second requirement is identification of the abnormalities, which are dark and bright regions. So these dark and bright regions are to be identified next. Then once these are identified, thirdly, we go for grading of diabetic retinopathy. So for grading diabetic retinopathy, we just identify how much or what is the amount of deposition of these abnormalities. For example, like for grade 0, if there are no microaneurysms on no hemorrhages, then it is called as grade 0. It is called as grade 1 if microaneurysms are present and they are at a count of 0 to 5 and hemorrhages are absent. Then the second case when is called as grade 2, where we have microaneurysms in a number of 5 to 15 and hemorrhages within a number of 0 to 5 and neovascularization is absent. Then the grade 3, which is the proliferative retinopathy, there we obtain higher amount of higher amount of hemorrhages, or we can also call it as proliferative if we see neovascularization, if neovascularization is present there. So using this scheme, we go for grading of diabetic retinopathy. Now, moving on to next case for identification of diabetic maculopathy, which is also a condition of diabetic retinopathy. So here we go for first identification of phobia, because detection of phobia location is essential for identifying or grading the maculopathy stages. Then once phobia gets identified, next requirement is identification of bright and dark lesions present. And then finally, the next requirement is identification of this bright and dark region in the foveal area. That means for macular edema grading, we have to identify these bright and dark regions in this region. Now, while identifying the stages or grading, as you can see here, this is the foveal region, and this is the outer region is at a 2 optic disc diameter. That means this region is 1 optic disc diameter distance, and this region is 2 optic disc diameter distance. Now it is called as grade 0 if anything is lying outside this outer circle. Then it is called as grade 0. That means diabetic maculopathy is absent. Then the stage is called as mild if it is present in the outer circle. This outer circle distance is from 2 optic disc diameter to 1 optic disc diameter. This region is from 1 optic disc diameter to 2 optic disc diameter. So this is called as mild stage. Then it is called as moderate stage when it is lying more nearer to the fovea. That means from 1 optic disc diameter region to 1/3 of optic disc diameter. So this distance is called as, if anything is present inside this region, then it is called as moderate. Then severe case is from within this 1/3 optic disc diameter region. If anything is present here, then it is called as severe case. So using this phenomenon method, we can identify the grading of diabetic maculopathy. Now, in case of OCT analysis, the primary requirement is to, as we can see here in this image, there are various noises present in this image. So these noises are nothing but speckle noise. So these are multiplicative in elimination of these noise is very much essential before going into any operation on the OCT images, because they create some false positives during our detection process. So speckle noise removal is the primary requirement of OCT image analysis. Then next condition is for diabetic maculopathy detection. For diabetic maculopathy detection, what we do here is we go for identifying of ILM and RP layer. Once these layers are being identified, then we go for identifying the thickness of ILM and RP. The thickness of ILM and RP, that means we go for identifying this regions, this thickness, and we compare it with the normal OCT images. Now, if the thickness is lying beyond the threshold, then we call it as the person is having diabetic maculopathy. Then once diabetic maculopathy is identified, then we go for further investigation by identifying of the cysts. As you can see here, these are the cyst regions. That means presence of the blood inside these retinal layers. So we go for identifying of the cyst region. Next case. So these are the requirements that we go for during an analysis of our OCT images. Now, moving into various challenges. So first challenge that we observe is the clinical challenges, which we observe during the eye examination. Now, the present scenario says that the doctor to patient ratio is 1:72,000. So for 72,000 patients, we have only one doctor. So if we can guess the scenario of evaluation where there is a maximum possibility of human error during the evaluation due to eye fatigue or due to various other stress conditions, the person that is identifying the diseases may get some error. So in order to remove this problem, what we can do here is we can go for automatic screening programs. So automatic screening program means we are going for detecting these abnormalities using automated algorithms. So these automatic algorithms, either if they are efficient enough, they can identify the disease, or at least they can help the doctor to identify the normal and the disease cases, so that the doctor can go for identifying of the disease cases only. The normal cases will be omitted. So if the normal cases get omitted, then definitely the time is saved. So this is the first clinical challenge that we observe. Next, for imaging challenges, while taking the image, we must be proper enough so that there are no issues that can be found. So there are the various issues that we obtain during the imaging conditions are due to the improper focusing or due to the improper balancing of the flash, we can get bright boundaries. So in a fundus image, we have brighter exudates. So those brighter exudates may share similar intensity with this brighter boundaries. So this brighter boundary may also get detected during the detection process. Next, background suppression. So in background suppression, as you can see here in this image, the most of the required informations are lying in dark. So in order to save this or in order to remove this, definitely we have to go for proper imaging. Then next problem is improper positioning. If the person or if the subject under observation is removing his eyes regularly during the imaging process, then this type of situation occurs, which will lead us to improper images. Then improper focusing. If the image is not focused properly enough, then we may face this type of situations. So in order to remove this, we may go for various solutions, like first of all for proper focusing and camera setup. And during camera setup, we must also check regularly if there is any dust particles present over the lens of the camera, because if there are dust particles present, we will observe some noises over the image. Now, next, in order to remove the outer boundary, we may go for field of view localization. That means we can eliminate this region because this information is hardly required by us. So we can eliminate this information and we can identify the area of requirement, and which is called as identifying of field of view. So as we can see in this image, the required informations are there and the bright boundary is eliminated. Then eliminating images with less information. That means, for example, this image, if we go for processing by various algorithms, then we can identify where we have lesser information. So we can immediately remove those images from our analysis. So various algorithms are used during these processes like color normalization, perfect transformation, then for histogram equalization. These are used normally for removing or to tackle up these challenges. Next challenge that we observe in case of OCT images is the speckle noise only. Now, during the imaging condition, if the person is not stable enough, or if the setup is not stable enough, then we may come across this type of images, which is lying on the right hand side. This is a normal or proper image taken by OCT camera, and this is slightly hazy due to the instabilization, or the either the person was not stable, or the table, or the system, that is, or the camera, there might be some difficulties. So in this case, what we can observe here is, as the image becomes shaky, the number of speckle noise increases. So in order to reduce the image speckle noise, first requirement is to get a stable setup. Stable setup means which means from the camera side also and from the patient side also. Then removing the multiplicative noises by proper multiplicative noise filters, which is the second requirement or the second solution. So now moving on to various challenges that we observe in case of fundus images. So for fundus image analysis, we require first optic disc detection. So for optic disc detection, during the optic disc detection process, what we observe is the optic disc intensity is similar with exudates. As you can see here, this is optic disc. These are exudate regions, and they exhibit or they share same intensities. So this is a challenge for identification process. So that is why we either first detect all the abnormalities or all the bright regions, and then identify the optic disc and eliminate it, or we can do it previously by detecting the optic disc and eliminating it, and then go for identifying the exudate regions. Then presence of, during the optic disc detection, another difficulty arises due to presence of peripapillary atrophy. That means, as we can see, optic disc should be circle or elliptical in shape, but due to some abnormalities or due to some presence of some pathologies, as you can see, there are few regions which are lying outside the optic disc. That means these are also bright regions. So if we go for detecting optic disc using by some using various algorithms of shape identification, then it might fail if there is a peripapillary atrophy. Then error due to severe retinopathy cases. As you can see, this is a severe retinopathy case, and here the intensity of optic disc is slightly lower than the exudates. So if we go for identifying the optic disc using algorithms like depend on the intensity, that means if we consider optic disc is the highest intensity of the retinal image, then that algorithm is going to fail here. So now various cases of identification, as we can see here, is the optic disc, as we can, is given in this diagrams. So the actual location is given by this plus sign, and the detected optic discs are given by this cross. So these are the difficulties of present in optic disc detection, or the challenges that we face. Next, for fovea localization. For fovea localization, first thing is suppression by background. So for fovea identification, suppression by background is a issue. For example, like if this type of images occur, we cannot go for identifying the fovea. That is why the fovea should be identified here, but due to the presence of this background suppression by background, the fovea is getting detected here. Then error due to optic detection. Most of the fovea detection cases are dependent on the geometrical relationship of optic disc and fovea. The geometric relationship states that the fovea is situated at a distance of 2 optic disc diameter and slightly below the optic disc center. So if the optic disc is not detected properly, then we cannot go for using this geometrical relationship. So error in optic disc detection fails the detection of fovea. Now fovea intensity. So fovea intensity, as we can see, the intensity of fovea is similar with the intensity of blood vessels and the hemorrhages or the blood leakage. So that is which makes it challenging for detection of fovea. Then error due to severe maculopathy cases. For example, as you can see here, this is a severe maculopathy case where the fovea is not at all visible. Similarly, here also, as we can see, fovea intensity is not at all visible due to the presence of the severe maculopathy case. So here, the algorithm might detect fovea wrongly in this regions. These red regions show the detected fovea regions, and these plus regions are the actual location of fovea. So these are the challenges that we face during fovea localization. Next is the detection of dark regions or dark lesions. So these dark lesions or hemorrhages and microaneurysms face problems due to the similar intensity pixels of blood vessels and also due to macular region. So this challenge has to be eliminated during the detection of hemorrhages. Now, during detection of hard exudates, as exudates exhibit similar intensity property and provide hindrances during detection of optic disc. Similarly, optic discs also provide hindrance during detection of exudates. So similar intensity pixels like optic discs and other abnormalities like autonomous spot or soft exudates we can have which provide difficulties during detection of exudates. Then healthy fundus image lead to blood vessels and macular reflection. Now, this topic I will discuss again during the discussion on detection of exudates. Now, these blood vessels and macular reflection, these are present in healthy images, but during detection, due to their intensities, we might find them as exudates. So these are the challenges that signal processing challenges that we observe in case of retinal image analysis. Now, during OCT image analysis, the difficulties are like, first of all, during speckle noise removal, when we go for speckle noise removal using speckle noise removal filters, if the filter is not appropriate, then which may cause blurring of the image. If blurring occurs, then that will cause the detection of various layers or cysts present. So that is why the noise removal should be proper and should not blur the image or remove the information of the edges. If the information of edges are removed, then it is difficult for identifying the layers or any other cysts present in the image. Next, detection of ILM and RPE layer. For detection of ILM and RPE layer, the challenge is during the whole ILM layer, we have various intensity regions. For example, the intensity that we find here in this region of ILM layer, that will be different from this region. So this variation in intensity may lead to improper detection of the layer. Then finally, while identification of cyst, there might be some false positive due to the background informations that are present. So elimination of background is required properly so that we do not go for or we do not face this problem. So we have seen already what are the challenges, what are the clinical challenges, what are the signal processing challenges during analysis of diabetic retinopathy using fundus and OCT images. So now in the next discussion, we will be going for the automated diagnosis process or how we identify the diabetic retinopathy, and also we'll discuss diabetic maculopathy. So now, first of all, there are various databases present which are publicly available. As you can see, these are I have provided few names here, and out of these GEI database and natural database, these are local databases that have collected from the local hospitals. Then other databases are available in the available publicly. Now, for detection of diabetic maculopathy, as we have already discussed, these are the stages. So these stages we have already discussed in our previous discussion. So to move on to first optic disc localization. So for optic disc localization, first we have to identify the localization of region of interest. That means the region that is containing the optic disc. So when we detect the region containing the optic disc, for example, as we can see this region, if we can identify, then within this region, it is very much easier for us to identify the optic disc. And this region is hardly affected by exudates. So first requirement is localization of region of interest, then searching of optic disc in the region of interest. So while localization of region of interest, we can use various properties like we can go for identifying blood vessel, then using blood vessel property, we can identify the optic disc. Now, while identifying the optic disc blood vessel relation is, as you can see here, the blood vessels are starting or they originate from the optic disc. So if we use this property, we can go for identifying the optic disc. And also we can see in the optic disc region, there are huge amount of blood vessels present. So that property can also be used for identifying the region of interest. So there are various algorithms like for intensity property, then using size property of optic disc. Also the optic disc is getting identified. Then color property, template searching, appearances. So these are various properties that we use for identifying optic disc. Now, the motivation behind detection of optic disc is, first of all, optic disc is identified for fovea detection, because optic fovea is lying at a distance of 2 optic disc diameter, as we have already discussed, which is used for also diabetic maculopathy classification, because for identifying these stages, we require the optic disc diameter. Then the main requirement is efficient exudates detection. If we can detect and eliminate or mask the optic disc properly, then we can go for efficient exudates detection. The next requirement is fovea localization. So for fovea localization, similar to optic disc, we go for first identifying of region of interest, then go for identifying fovea in the region of interest. So for localization of region of interest for fovea, we go for two properties, that is using geometrical relationship with optic disc, that is of 2 optic disc diameter. This geometrical relation we use. Then we can also use geometrical relation with blood vessels. Similar to optic disc, from blood vessels also similar condition is valid. So that is why we also use, or people have also used, blood vessel relationship for detection of fovea. Now, during the searching of region of interest, we go for various properties like intensity property, template searching methods, then appearances. These are used for identifying of region of interest. Then once the region of interest is identified, then using intensity property or by some localization properties, we can detect the fovea region. Now, during fovea localization, our prerequisites are optic disc detection and blood vessel detection. Now, there are few algorithms which can identify fovea without detecting these regions, but those are applicable for the normal images, because during abnormal images or during pathogenic images, there are various other objects which are present near the macular region or in the neighborhood of macular region. So those will create some difficulties for detection. So that is why for during disease cases, these are prerequisites. Now, the motivation of fovea identification is to assist diabetic maculopathy classification, because considering fovea at the center, we draw the concentric circles. Then, without optic disc detection dependency, if we can detect fovea localization, that will be very much effective, because we move out of the error which is caused due to improper fovea localization. Then efficiency in pathogenic cases. That means if you can identify fovea in pathogenic cases, then that will be more beneficial in case of cases where we face higher amount of depositions or the severe cases. Now, as you can see here, this image shows the fovea region hardly contains any blood vessel because the blood vessel growth starts from optic disc and it moves towards the fovea. But before reaching the fovea, the blood vessel growth completes. So that is why fovea region is also called as avascular zone. So using this property also, we can identify the fovea. So, and while using this property, there is hardly any requirement of optic disc detection. So we can go for an efficient detection here itself. Now, for bite lesion localization, our requirement is to, or motivation is to assess the diabetic maculopathy classification, then eliminate the other bright regions and eliminate reflections. So, in order to get this, what people have done is there are various methods using supervised and unsupervised learnings. So in case of unsupervised method, there are two types of methods called as direct methods and indirect methods. In direct method, what we do here is we first go for suppression of the background or subtraction of the background. Then we identify the bright lesion detection using various algorithms of age detection, morphology, thresholding, and active contours. Active contours. Then elimination of these regions other than hard exudates is done. So to remove this, we have to identify our algorithm should be efficient enough so that it can segregate the hard exudates from the soft exudates or other bright regions of the image. Then post-processing is required for elimination of the false positive, which are caused during the detection. Then in the indirect method, we do not identify the exudates, we go for identifying the regular regions by using region-going algorithms. So this region-going algorithms, we identify the continuous or regular regions, and once it is getting identified, if we go for inverting the image, then the remaining regions are nothing but exudates. Then in supervised method, we go for direct feature generation methods. Then this can be also done by segmenting and then identifying of various or generating various feature generations. Now, during this methodological analysis, we face various difficulties or we face various issues like during age detection may yield noisy results due to variational boundaries. Then local schemes only detect maximum exudates and global scheme detect the brightest pixels. And the machine learning methods require extensive pre-processing, and in case of supervised method, we require proper ground data in order to classify. So these are the methodological causes which poses challenges. Now, the part which I have not discussed, that is eliminating of the retinal reflections. So as you can see here in this image, this is a normal image, and during that normal image capturing, we find some bright regions. These are nothing but reflections. These are blood vessel reflections, and these are, as you can see, these are macular reflections. Now, these are also bright in structure. So, if we are detecting any intensity algorithm for detection of the abnormalities or the exudates, then these may also get identified as exudates. But actually, the condition is the person or the image that is a normal image or a healthy image. So we have to eliminate this type of images during the process. So similarly, in case of dark lesion analysis, dark lesion localization also, we go for similarly unsupervised method and supervised method. Same process is carried out here, and we go for identifying this for DM classification and for eliminating of blood vessel pixels. Similarly, methodological cases are also similar as bright lesion localization. So during the diabetic maculopathy analysis, as we have already discussed, there are various regions, and these regions are identified using the property of optic disc diameter. So we identify first the presence of the abnormalities in this region, then you identify the area that is covering this region using these formulas. So the challenges here is the proper optics detection and proper foveal localization. Because if these two things are not proper, then there will be definitely error while detecting the stages. So now coming to the final discussion on OCT analysis. So for OCT analysis, the motivation here for the analysis is requirement of or elimination of the speckle noise present, then detection of layers despite of intensity variation, and then background normalization, which is required for cis detection. So during this process, first, in case of our noise removal algorithms, where people have used various algorithms like median filtering, low pass filtering, then bilateral anisotropic diffusion filters are also done, and nonlinear complex diffusion filtering is also done. So in these cases, the comparative studies have shown that normally while using median filtering or low pass filtering, they are susceptible to blurring, or they eliminate the edge information. So hardly these filters are being used. Then if we go for some advanced filtering operations, we go for bilateral and anisotropic diffusion filter. They preserve the edge informations, but the difficulty with these filtering options are that they create some cartooning effect. That means there are ultimately the edge information will be lost in certain regions. So people have also used statistical modeling for removing of these noises. Then for layer detection, there are various algorithms like one-dimensional gradient peak detection method, then two-dimensional edge detection methods, and three-dimensional graph searching methods are also used. Then for cis detection, people have used various thresholding methods and active contour methods, which have given various results and findings. So these are various possibilities or various methods that we use for detection of diabetic retinopathy using OCT images. So with this, I wind up my discussion here. So these are the references. And you can reach me.
Thank you so much, sir.
Thank you.
Thank you for your informative session, sir. Sir, we have some questions. Can you please stop sharing your presentation so that I can present the questions, sir?
Yes, please.
Sir, is it visible, sir?
Yes. Yes, it is visible.
Okay, sir. These are the questions.
Okay. So first question is, do we have a specific benchmark data set for fundus images to work on this? So for earlier, as I have given few names, so out of those, there are nothing as we can call it as benchmark, because people nowadays are all using all the databases. So the database sharing started from Drive database. So Drive database is, as we can say, is the benchmark, but nowadays that database is also absolute because there are only 40 images. Presently, there are various databases which are providing images more than thousands. So generally, whatever databases I have given, all those databases are used for detection of this diabetic retinopathy or diabetic maculopathy cases. So we can use all such images. Next, second question. According to Moore's law, how many states that machine learning required and human required to come to a conclusion or prediction? Actually, I am not clear with this question. Ma'am, can you help me?
It's okay, sir. You can proceed to the next question, sir.
Okay. Diabetic retinopathy diagnosis using retinal. When will start? Is it a question most probably for the discussion of the slide? Is it? Because retinal images are nothing but fundus images, OCT images. These are retinal images only. These are two processes of getting retinal images. In two-dimensional cases, we go for analysis using fundus image, and then for three-dimensional or the layer information, we go for OCT image analysis. So probably I have answered this.
Yes, sir. Yes, sir.
Kumar, thank you. Then next question is, which CNN is most suited for working in fundus image set? This is a general thing, as we can say, because all the algorithms will operate in case of fundus images. And the thing is, we might find difficulty in all the algorithms also, because the fundus images are not similar or we can say that in case of the real-time analysis, the fundus images are very difficult to detect, or the abnormalities are very difficult to detect. So some methods may be operational for few databases, and they might not work in the same manner in other databases. So we cannot directly say that which CNN will be more suited, because it will be dependent on how much error we are getting, how much error we can minimize during the detection process. So we can try with start with the basic ones, and we can go to the higher ones also. So next question is, what are the best research institutes for diabetic retinopathy? Research institutes, as far as my knowledge is there, nowadays this analysis are these detection processes are being done, or researches are being done in almost all the institutes which are having biomedical studies. For example, in most of the IITs, in IIScs also, they are doing researches. And if you are asking about other, the question is on this detection of research in companies, or if you are asking for any such companies which is currently providing this diabetic retinopathy analysis, then I can suggest for there is a company called as Forus Health, which is working on this area. Next, so next question is, can the damage due to diabetic retinopathy be reversed? Yes, it can be reversed at earlier stages, but if the higher stage, if the person is facing the higher stages, then it is hardly can be reversed. Yes, it can be minimized. Therefore, that is why people go for laser operations, so which minimizes the effect, but it cannot be reversed. So next question is, can you name few automated screening algorithms? So for automated screening algorithm, we go for various algorithms using. There are various machine learning tools. So like we can use various CNN algorithms. CNN as it is given also earlier, CNN methods. Then various algorithms or level set algorithms are far better than the other processes, because they consider detection of variational layer boundaries. Then people have used various classifiers in this process, like starting from Bayesian classifier to neural networks. But presently, everyone is working on deep neural networks. So obviously, the current scenario is moving into deep learning in this area. And then next question is mention the algorithm used in image processing. So there are various algorithms we can use, starting from the threshold detection up to machine learning algorithms. So there is hardly any limitations. So we can go for all the algorithms depending on how they fit to the images. Because some algorithms may fit for a particular database but may not work in the other databases. So that is why we have to check for various algorithms during the detection process. And is the NetRail database? No, NetRail database is not publicly available actually, because there is a process that has to be carried out for getting their images. So it is not publicly available. So last question is, which process will give more accurate results, retinopathy or blood sugar level? So if we are detecting retinopathy, then definitely we are to go for retinopathy analysis. Blood sugar level will detect the diabetes, not retinopathy. To understand retinopathy, we have to go for definitely the detection using either fundus image or OCT images, or both. Thank you.
Thank you, sir. Once again, thank you for your nice explanation, sir. The session was full of information and which was excellent answer. Thank you, sir.
Thank you. Thank you.
So we are also looking forward for your same support in our future event as well, sir.
Thank you.
Thank you so much, sir. Thank you.
Thank you.
Participants, today we come to the end of the day 3 of MLCV 2020, and tomorrow we will meet at 10 a.m. on the same platform. So have a nice day. Thank you. Thank you, all of you.